Mitch Miller here for a comm check. Everything went silent for me.
Hey, Mitch, this is Bill. This is Bill Cooley. I can hear you loud and clear.
Awesome.
Good morning, Colonel Bartolome. I can see you. Your video is working well.
I had a green sticky covering the camera, so.
Oh, that's what that was. Okay, good. I thought maybe you had a strange background I wasn't aware of.
Nope, just a good green sticky.
Not everything has to be a digital solution. Good morning. This is Major General Bill Cooley. Welcome to the Digital Campaign Virtual Industry Day and Engagement. We're working through some technical challenges to make sure Dr. Roper gets logged in, and I believe General Bunch is on the line and ready to go. So if you can go to this is the title slide. If you can go ahead and go to the next slide for me, I'll show you the agenda of items. So we're going to start off with General Bunch having some opening comments. Then Dr. Roper is going to share his vision. I know that he sent out to many of the industry colleagues and counterparts his updated document, about a 19-page document talking about where the Air Force is headed. He'll talk about that. The question and answers, there's a little bit of a delay between what we're presenting and what is being broadcast. So we ask that you push your questions into the Q&A section, and we will work those into for Dr. Roper in that time period. And then once we'll go through a number of exemplars, key programs. Then we're going to break and talk into some of the specific activities that the entire that AFMC has been largely pushing under General Bunch's leadership, but it's been an enterprise effort engaged with headquarters and the Space Force and others, and then we'll wrap up with questions and answers. So with that as an introduction, I'm going to turn it over to General Bunch for opening comments. Sir, over to you.
So good morning, everybody, and well, it's morning here. Thank you for being part of today's the Air Force's first Digital Engineering Virtual Industry Day. I wish that we could all be together, and I wish we weren't fighting the technical challenges, but that's not the environment we operate in today, and we need to move out on this. So I appreciate you participating, and I look forward to a dialogue. I want to do a shout out real quick to all the folks that pulled the virtual part of this together. Nick Schaus, Diana Leonard, Steve Alexander, Marissa Alianovabulski, Richard Hoyles, Mary Allen. As you can imagine, trying to hook this up, I think we've got about 1,500 plus dialed in. Trying to make all that work in a virtual environment is no easy task, but I appreciate their diligence getting it all together. Today is an opportunity for us to share and get your comments and your feedback. As Bill kicked off, this is an effort that we started as a team back in the late February, early March timeframe with AQR, with Space and Missile Systems Center, with all of Air Force Materiel Command Centers being represented, as well as all the program executive officers, laying out what we thought it would take to go to a digital engineering and have a digital campaign across AFMC that we hope will grow out even broader. So today is your opportunity to let us know those areas that we kind of haven't thought our way through and share some of your experiences. Why digital engineering and why digital campaign? You know, multiple years, we have talked about speed to the field and how long it takes to develop things. We've talked about how technology and our adversaries or potential adversaries are not stagnant or stationary, and how that they are continuing to evolve at an ever quickening pace and push that technology boundary even quicker. You know, if you look at the National Defense Strategy, it talks about fielding technologies at speed of relevance. It talks about increasing readiness and lethality. It talks about decreasing bureaucracy. It talks about great power competition. We built our strategic plan in AFMC after looking at the National Defense Strategy and the Air Force we need. We had 4 lines of effort: increasing readiness and lethality, speed with discipline, strengthening our team, and fostering trusted communications. If you look at all those needs for speed, all the national defense strategy and what we're doing within AFMC, and you actually look at what General Brown's put out now with Accelerate, Change, or Lose, digital engineering and a digital campaign touch on all those things and enable us to move forward. Digital engineering is one of those areas that I applaud Dr. Roper on, because he started pushing this as soon as he got into his role and when I was his deputy. It's been one of his focal points. It provides the opportunity for open collaboration across not only all of AFMC centers to positively impact the life cycle of systems, but also all of the Air Force requirements, AFWIC, and our industry partners. Open modular systems, standard architectures, cloud computing, tech stacks, and all those and more provide us the opportunity to change the way we do our business and to accelerate. Provides us the opportunity to identify issues earlier, the opportunity to reduce tests, the opportunity to better prepare for sustainment, the opportunity for more robust and refined requirements trade, and much, much more. We have demonstrated, and the agenda today, you're going to listen to 3 of our exemplars. We've demonstrated the value of this approach in pockets. Now we need to get to where we more normalize how we execute and we apply this more broadly. At AFA last week, Secretary Barrett rolled out E-Series designation for programs. And Dr. Roper shared his vision for digital engineering and gave some real world examples of how we've successfully done it. So we're moving in this direction. It's also why I'm so thrilled that Dr. Roper is able to join us today so that he can share again that vision and take your questions and put a more refined context on what he's looking for. The policy requirements and strategies on our acquisition programs driven by Dr. Roper's vision are going to shape how we do this campaign and what we implement across AFMC and across the Air Force. It's why that partnership between what we're doing at AFMC and AQ is so critical, and why it's so important that he's able to be with us today. For industry, I'm sure that each of you has your idea what digital is and what it means, and you've got your examples and experiences, and you can exchange those. I ask you to share all those lessons learned and those ideas so that we can move forward together. We look forward to working with you so that together we can successfully keep our Air Force's position as the world's most dominant Air Force. Thank you again, everybody, for joining us today. And Bill, I'll pass it back over to you.
Thank you, sir. Thank you, sir. My hope is we got the slide up for Dr. Roper, and I'm told that he's going to dial in. They're having some technical challenges, but Dr. Roper, can you hear me all right? And if so, the floor is yours.
Still working.
Okay, I'm told that they're still working to get Dr. Roper dialed in. Just give us a minute.
can hear you typing. You're live.
All right. Well, oh, that puts you in a great mood having to fight with IT when you're going to talk about digital technology. So clearly we have not gotten off to a great start within the Air Force. First and foremost, I just want to thank everyone from industry who's joining. This really is beginning a discussion with you, and just please forgive us. We're going to be a little disjointed as a government team today, and that's okay. This is something where we've all got to learn about how to bring digital engineering to bear across the entire life cycle. And I've had no time to speak with any of the presenters that are going to be here today. I think most of you know that last week at AFA was a really big push on behalf of the Secretary and our two chiefs on digital centricity and especially digital engineering as a centerpiece for how we approach future programs. So part of today is just really to lay out what we think right looks like, but then also to hear from you. And if you hear different voices within the government, that's because there's a lot for the government to learn, and we don't believe and don't have the audacity to say that we know what right looks like. We can only say what we think it looks like, and then hopefully learn from your experiences in your companies. I'll share a few things that have been popping up for me as I've tried to wrestle with how to give guidance to our program teams. But really, most of what I believe about doing digital transformation is in the Matrix-inspired document that I put out. So I hope that you'll take the time to read it. A link was passed out early this morning on the final draft to most of your CEOs and vice presidents. But if you didn't get that, please contact us and we'll push the link. And I think it'll lay out in hopefully a humorous, entertaining form what digital is doing in a handful of programs, as well as in commercial industry, that we can harvest for an advantage in our defense programs that no technology I've seen in 8 years of looking for game changers has brought to bear, which is why I'm just so excited about it. I've been looking for a way to build a better building process as we compete against countries like China, who can throw labor at us, who can throw cheap labor at us and beat us at a sense of scale we're simply not going to match in this country. A technology that can undercut that can't be beaten by cheap labor, that puts the emphasis on skill and technology, is one that's highly appealing as a way to help level the playing field. And I think digital engineering and digital transformation have the potential to be that. So I'll cover what I've learned from having a lot of discussions with commercial industry, what I'm seeing in a very small handful of programs in the Pentagon that are radically digital, and then what I would hope for the future. And then I would be more than happy to take any questions today from anyone that's online. I think the first and foremost thing is we need to get specific very quickly about what digital engineering means in programs. I don't want to see the same trend happen in digital engineering that happened in agile software development. When that first started popping up in the software factories like Kessel Run and the many others we have now, agile went across the Pentagon and across industry, and it was a term almost anyone could use if they were trying to do things quickly. But it completely ran past the different technologies upon which a modern tech stack is built. And so you could say you were doing agile if you were trying to work quickly, but it didn't tell us what technology you were using. And the technology that undergirds your development and deployment is everything in keeping up with tech trends. And so as software started changing from a discussion on agile to one of more specific technologies like containerization and service mesh and zero trust, that was hugely helpful for me because it became a 1 or 0, an on-off switch that I could talk about with program teams and with companies like yours that would tell me yes or no. Are you ahead of the wave that commercial industry is crashing towards the shoreline, or are you behind it? And of course, with as quickly as these commercial waves are moving, we've got to stay ahead of them. And so digital engineering is something that I think can go the same way if we're not careful. Every program that we have is using computers in some way, shape, or form to design, to code, to deploy aspects of the program. And if that's what we mean by digital engineering, then everyone is doing digital engineering, and we've been doing it for decades. And so that's not going to be a fruitful discussion. It'd be very much the same as saying that if you built a sculpture using a hammer and chisel, that all sculptures ought to be the same. Clearly, that's not the case. The art is in how you use the tool, and it very much applies to digital engineering. And so before we made the big announcements at AFA at the secretary level and on down, I really had time to go on an odyssey through commercial industry with the help of a lot of great companies, a lot of great consulting firms who helped me learn what their digital transformation entailed so that we could determine how much of it we could bring into defense. And I'll give you some examples, but I'll go ahead and cut to the chase. I haven't seen anything yet that I don't think is applicable to our mission. And that's wonderful. That means this technology is being de-risked by a lot of early movers in commercial industry. But by no means is this technology fully realized within commercial industry. Sectors like the automotive industry and microelectronics to some degree have already started moving to fully digital operations, fully digital engineering and manufacturing, but no one is completely there. Automotive is probably the closest. And industry fields that are closer to ours, like aviation and space, still haven't moved yet. So for once, the Pentagon and particularly the Air Force and Space Force are not behind. We're going to get to learn alongside commercial industry counterparts, and our timing really couldn't be better. So that's the first good news, is that we're not as behind as we normally are, but that should make us feel better. This is happening right now, and we need to be happening with it. A lot of the examples that I found in commercial industry, unfortunately, are proprietary to those companies. So it was very good for me to learn as the acquisition exec, and they are examples that I'm very excited to share with our government team, but they're going to be harder to share more broadly with industry. There are very few of these world-leading lighthouses that are recognized by independent engineering and manufacturing association. There are 44 worldwide, but only 4 in the United States, 13 in China. So 44 is not a lot, and that should tell you that to get to that end state of having a radically digital, a radically different, because of it, operation, that there's a lot of hard work to put in place, and it's harder than meets the eye. If it was as simple as bringing in a lot of computers, there would be a lot more than 44 lighthouses right now. And that should tell us that there's a lot that we can get wrong. And I absolutely believe that that's the case within defense programs. But there are some general things I can share that I've seen across industry. The first is that design speeds up and that engineers get to be engineers. And the latter is a wonderful statement. I think that has been one of the horrible trends that's happened in the government over the last couple of decades. It's been mirrored in industries, in defense, and in companies like yours. That if you join to be an engineer, we don't give you a lot of time to do it on any one program, and then there are not a lot of programs to do it over the course of your career, especially as we decompose requirements and then hand them to industry that further decomposes them into system, subsystem, the subs, all the way down to the individual components. And by the time you're attacking the integration of those subsystems all the way up to the integrated system itself, the need to do that in series and to lock down on configurations so that you can de-risk integration, which has been a cautionary tale of acquisition in recent decades, is that we've undervalued integration risk. Then the engineering time for engineers is very little. We're mainly working integration as engineers, very little on design. And so if you want to come into defense to be a designer, sorry, you're not going to get to do that for much of your career. You're going to do a whole lot of the things between the things. The first thing I've seen in commercial industry and in a handful of our programs is that the time for design and engineering stays open much, much longer. That design reviews can happen continuously and concurrently and in parallel all throughout the engineering, manufacturing, and design phase of a program. It's amazing because the things that we typically fear in acquisition, like concurrency and integration risk, get handled by the tools themselves if you do them right. So when commercial industry gets it right, the tools are doing the integration. That's the magic of what I see this doing in design. I think there's a huge potential for us being able to explore concepts longer, being able to avoid nailing down a baseline early, which gives us more opportunities to attack risk. So that's thing one. Thing two, I've seen commercial industry significantly lower the burden to move from design into assembly, but only if they create what's called a digital thread, which we have a couple of examples of in defense programs like T7 or ground-based strategic deterrence or next generation air dominance. This is a very important term. It's important for you if you're in the government, it's important for you in industry. We can't turn this into a term like agile or any of the other software buzzwords. This has to really mean something. And we don't have to be perfect in building up digital threads to get amazing results. But what it is are connected models that cross at least two of the life cycle phases of a program. So in a perfect world, you'd go all the way from your design to your suppliers to assembly to operations and flight if it's an airplane, all the way to maintenance and then retirement. You would have all of those models integrated together and be able to explore all facets of the life cycle concurrently. And there are industries like Formula One racing that have exactly that. And I'll come back to Formula One. It's a hugely inspiring use case and I think shares a lot of commonality with our mission. But you don't have to have that to make a big impact and to truly reduce what would normally be a big risk in a program. Just having a set of connected models that move from design into assembly that also tie to your supplier base can allow you to explore forms of assembly like determinate assembly that have not been doable in defense in the past and create ways of building things that are simple and faster. And that's fairly common in commercial industry as well. This desire to lean out as much touch labor as possible to simplify facilities and tooling so that you don't have specialized tools for specialized systems anymore. You're either using simple tooling or more generalized tooling so you can build multiple things on the same production floor. Think automotive industry. I think there's a huge potential for this to cross over into the Air Force and Space Force, especially given that airplanes and satellites and weapons often require a high skill set, a high degree of specialized tooling and specialized facilities to put together. And that will probably be the case in some respect, but the more that we can simplify it, the faster we can go and the lower the integration risk should be. And so I've seen that play out in automotive industry, particularly in companies like Tesla, and I've seen the same results mirrored in programs like T7 that have produced effectively learning curve killing results. So learning curve being completely addressed with the digital thread, completely retired in the digital world, which is amazing. That's science fictional if we were talking about that 5 years ago, and it's science fact today. So that's a second trend of this digital thread allows you to do more things between the things. And it allows really, what I see is allows the next phase of the life cycle to jumpstart early and begin doing its work while you're still in the phase before it. So if you're a manufacturing engineer and you are typically waiting for drawings to be done and prototypes to be built before your time in the sun really kicks off, not anymore. You are working your process from day one. You are influencing the way that systems are designed based on manufacturing and assembly. And if the digital thread goes all the way to the end, and we've had examples of this in GBSD, then even a maintainability or a sustainability engineer is working their part of the life cycle at day one as well, inputting their design request or constraints all the way back up at the beginning. And because the thread, that's why it's called that, the thread is connected all the way through without being disjointed or cut, then the integration of those different phases happens automatically in the background. It's super fantastic. I really, really wish I could go manage a program with this tool, because it's like having godlike powers because of how much automation is happening in the background. So that's another thing that I see in commercial industry that I think that we can bring to bear. And a final thing is one that has not fulsomely crossed into defense, but I could see this happening in future, which is where we move a lot of our training, test, and ultimately operations into the digital world, and bringing in digital twins as a way to evolve. And digital twins and digital threads are separate. But Formula One's a great example for this. There are no more prototypes in Formula One. The entire design, the entire development, verification, training of the driver, all of that's done digitally because the models are that good. They're one-to-one with the real world. And if they weren't, it wouldn't be what racing teams would use, but it's how they win today. The digital world actually supersedes the physical one. But because you actually have to win in the physical world, they do produce a final car about 2 weeks before the race, but it always remains tied to the digital one. It's this digital twinning concept. And the really cool thing is that as a car is improved in the digital world, it actually gets those improvements from a software perspective in the physical world, and vice versa. And that's a hugely powerful concept, especially if we aspire to bring artificial intelligence into the joint force, and we should. We can't train it in real time. That's a losing strategy. And so by getting digital engineering set up correctly and getting digital threads pulled off across the entire life cycle, if we take the next step and bring in digital twin technology, so when the physical thing exists, if we make sure that it remains coupled to the digital twin that it has, then we give ourselves the potential to move into faster than real-time training. And I think that's going to be critically important for software. I think it's going to be critically important for AI. And we don't have the ability to do it currently. So a lot of things couple into what we see commercial industry doing well. So when you leave with those kinds of insights from commercial industry, the first thing you want to determine is what are we doing well within defense programs. And if you're an industry, or if you're a program team or an engineering team or a test team, and you're thinking, you know, boy, I haven't really heard of this before. I've heard of it, but I really thought it was more about using computers. I didn't really think it was about trying to take the entire business of what we do digitally, at least attempting it, and then reserving for the physical world only those things that we certainly or would not be advisable to anchor in the digital world because we lack the data. And I think our mission is always going to require real world data, but our reason for getting real world data should be to come back to that digital world, right? The digital world is really where we're living. It's where we're engineering. It's where we're testing. It's where we're training. What we do in the physical world is really meant to create more data for the digital world, which is a complete 180 from where we've been. We've designed with computers to go fly before we buy and then go produce what we've flown. Flips that paradigm. So if this is the first time that you're hearing that, just the first thing, you're not behind. There are only a few examples of this. There are only a few industry teams that are knocking it out of the park. There are a lot of industry teams that are showing me examples of digital engineering that have those words in their white papers printed on their PowerPoint slides, but their programs show no delineated example of performance improvements. It's just digitizing the way we've always done business. And that's simply not going to be the hallmark of what this trend needs to bear out, which is a delineated, a step change function advantage over the way we've done it in the past. And if you make that your litmus test, then I've only got 3 examples right now, though I hope that we'll have more in future. So, and those you know from AFA last week, T7 program started, but there are 2 airplanes out flying, and they are remarkable in that they're identical. And they were built with that first tail having the same quality as the 100th. So learning curve being de-risked and tackled digitally. An amazing feat, and one that we can replicate on anything else in future if we aspire to that level of digital prowess. Ground-based strategic deterrent is another, an amazingly complex program. It hasn't built anything in the physical world yet, but it has the most complicated digital engineering environment yet produced within the Department of the Defense, to my knowledge. And the great news, aside from all the amazing modeling that they have done in their sandbox out at Hill Air Force Base, is that it's not just available to that program. We're going to be hosting it on our enterprise-wide platform so that any program team can use the same set of tools. And this is something I'll come to in a second. This idea of building up the tech stack and sharing it across programs is absolutely part and parcel of the direction we are going in Air and Space Force. In fact, though it is possible to do a program without a government furnished tech stack, I believe in future industry will be asking us for that, and I'll share that why at the end. So GBSD is doing amazing work, and of course from last week, Next Generation Air Dominance, as many of you now know, has demonstrated getting to a full-scale flight demonstrator, and it's really all we have to say, but it tells you that the digital engineering approach that we're applying is not different when you're going after a next generation aircraft than it is when you're building a trainer. In fact, the more complicated, the more risky something is, the more digital engineering makes sense. The more you are likely to see amazing results, the more complicated what you're trying to do is. And so, although it's amazing that we've gotten to a full-scale flight demonstrator, really, if you believe in digital engineering, it shouldn't be. It should just be normal. And I'm glad that we've got that fact out in the world, because I want this kind of expectation to be normal. It is, if you get the tools and the models and their interconnectivity correct. All right, so we've got a few examples in defense. So with putting out the matrix-inspired document, what's the so what? So we use computers, we connect the models. So what will? What's the big paradigm shift that we've got to pull off to make this work? If you take nothing else away, the big thing that we're trying to achieve with digital engineering is so much more than just the base level of having interconnected models that also connect to our supply chain and assembly process. It's a noble ambition. It's been done, but it's noble to continue aspiring to it in future programs. But there's so much more we can do and we'll have to do if we want to truly be the disruptive designer and fielder of capabilities and also do it in the digital age. And that thing is putting increased automation, unprecedented amounts of automation in the tech stack itself. It's already been demonstrated in a program like GBSD that's leveraging the Cloud One Platform One software development tool. So Cloud One Platform One is a government-owned, fully container-native Kubernetes software development platform. It has an authority to operate that is continuous and baked into the stack. And when we share it with industry, industry gets that authority to operate as well. We can let it convey because it's government-furnished infrastructure. And maybe that's not reason enough to think that we ought to be doing programs in future sharing a government-furnished tech stack. But once you see what's possible with having security embedded in the tech stack itself, happening automatically in the background, then it opens up your eyes and your aperture to what is already common in commercial industry and can be common for us. And that's trying to automate nearly everything we do. So much of what people do today is done by check boxes that are checked, steps in a sequence that are done in series, not in parallel, that can be automated and put in the background of what's happening in the tech stack all the time. So things like safety certification, tests, nuclear surety, Seek Eagle, airworthiness. We may not get to 100% automation, where if you design something in our tech stack, you assemble it and you go ahead and go out and fly your first day off of the assembly line because it's certified as safe and able to carry weapons and all of that. But what if we get 80% of what we do automated? What if it's only half? Then we've revolutionized the speed at which we can go, and we've allowed the people on both of our teams, both the government and industry, to really focus where people need to do the heavy lifting and the critical thinking. That's the direction that we're going. We want to automate as much as we can to speed up process for certification across the board. And to do that, we're going to have to furnish you a tech stack that's worth a damn, that is able to keep up with program needs. Now, two things that we'll have to do to pull this off. One is we'll have to have one that we can scale across industry. And so far, so good, but we're only dealing with a handful of programs right now. What happens when we're talking about every program and every function across the Air Force and Space Force? Well, that is another level of IT altogether, and we truly will have to treat it like a warfighting system, or simply put, we, the government, will be on your critical path. The next thing we'll have to do is create a government reference architecture for that tech stack, because you, industry, are going to need your own in order to do your own internal work before you cross over and join our tech stack in a formal program. And we should be able to do that in a way that is absolutely seamless and one-to-one. And programs like GBSD have demonstrated that. But we can't jerk you around. We have to have the technical acumen on our team to be able to tell you how to build your stack so that when it's time for you to be on contract, it's seamless and one-to-one with ours. And then once you're on ours, all of that government automation that we've been working on together comes to you as just free of charge GFE that directly reduces your risk, your integration risk. And so far, talking with company engineers and coders and program managers who have gotten to experience government automation on their industry work breakdown structures, doing those in a government automated tool with government automation in the background helping them, traces directly to how much risk they have, and pulling down that integration risk and putting more clarity and sentience on industry's side so that you're not waiting on delivering that document to a government certifier and wondering when it comes back. You're 7 green check marks away that happen in less than a minute in our cloud, knowing whether or not what you've done meets whatever certification you're achieving. And that is exactly how many commercial companies run today. Huge amounts of automation simplifies and reduces the size of their teams, but the technical talent of every team member goes way up. I'm very confident that we can do this. We already have teams that are working on an initiative called DevStar Ops, which is referenced in the Matrix document. And again, if you haven't seen the Matrix, I'm sorry, you will probably have to watch it to make sense of this, but it's a good movie to watch to get you to think about what happens when you're living in a physical world that also connects to a digital one. I think it gets your headspace about how far you could go. And so as you go through that, DevStar Ops is mentioned. We already have teams of people taking on the next generation of automation in our tech stack. And as you, industry, join our teams, that's going to be the challenge from me to you. Is whatever we need to automate for your program, we will, but it has to go back in our government tech stack so it's available for all thereafter. And every new program makes the level of automation, makes the richness of the tech stack better and better. And as we get better, we move faster. And as we move faster, we're more disruptive. And being disruptive and agile is the only way we'll compete against an adversary like China that can outmatch us in every form of scale. If we can't win en masse, then the clock has got to be our ally. We will have to be faster than they are. And a technology like digital engineering, combine it with agile software development and open architecture, seems to me to give us the kind of agile approach to acquisition that we have been lacking in the post-Cold War era. So you couldn't find me more excited about this. I'll be writing more implementation guidance specifically to our workforce very shortly, putting out guidance on what e-system criteria are. As another thing the Secretary has announced is we really do want to design full systems digitally. It means something to us, just like a physical system would. So a lot more to come, but it's never too early to start the dialogue with you. And with that, I'm happy to take any questions for the time we have remaining.
All right, Dr. Roper. Yeah, this is Major General Bill Cooley. I'm playing MC here. We have some questions that have been posted and folks are able to vote on them. And it looks like the most popular questions relate to how. How does industry work towards the MBSE, modeling, simulation, analysis, interoperability, and convergence of government with industry? There's another question that sort of says, okay, we've got PLM and finite element models and those kinds of things. How do we fall into and collaborate smartly so that we're not, building up separate capabilities, if you will? Over.
Copy. So there are two things, and you'll have to be brutal in industry. First is we owe you pronto our government reference architecture. And remember, we've just started. So we're going to have to leap far ahead of our needs and provide industry the reference architecture we will be using for our tech stack so that it is easier for you to jump from internal developments into a program of record. For programs like GBSD, they had to begin by the program saying, here are the tools we're going to be using and you industry will use them as well. I think it's much better to give you the ability to skate ahead of the puck. With respect to models that you have now, as you build out your systems to comport with our government reference architecture, and by the way, depending on what industry would want, I'm not against just GFEing our government cloud platform, MBSE as a service, data as a service tools. I'm not against doing that. That's what industry would like, but I imagine you may want the ability to have something that you control as well, but they've got to be simpatico. And if they're not, then anytime we move from you to us, we will begin again what you've already done internally because of the artifacts of moving from one version of truth to another. We have to have an authoritative truth that does not change as we move between different tech stacks for design. For models that you have, it all really depends on whether you can put them in that government reference architecture. If you're able to do that and trace between whatever it's modeling and the other facets of your life cycle, even if you can only bridge between one phase, then you don't have to restart. And if the model really is a good reflection of reality, then you should be able to do that. It'll just be a question of the interfaces. How does it talk to the external world? Is it just something that you go and it spits out numbers or tolerances, or is it able to output the functions of its model in a way that are inputs for other models? You may need to refactor, you may need to rehost. I know that'll suck, but it's worth it. If you cut that digital thread any place, it's a limfac. It's a limfac for your competitiveness. It's a limfac in terms of risk for our programs. If I were in your shoes, it would be the first and foremost investment that I would make, is getting to one integrated digital engineering environment so that you could turn over to your teams when it's time for a new program and be able to trade things across the entire life cycle, bringing your full value proposition as a company to bear, not just your value proposition in whatever model you happen to have available at that time.
Okay, thanks. Before I ask the next question, a lot of questions have been asked. Hey, how can I get my hands on the matrix document? For everybody's awareness, it is posted within the Q&A, sort of in the middle range of if you sort by likes, but that document is available and everybody should be able to access it. Next question for you, Dr. Roper, has to do with how do we incentivize the entire workforce? How does SAP AQ intend to train and incentivize the entire DAP acquisition workforce to move towards digital fluency and make this vision a reality?
Well, it's going to happen with my good friend General Bunch, because the training is going to happen on the AFMC side. You know, General Bunch is going to have to get the entire acquisition workforce ready to be a digital one. It's my job to do what I'm doing here and in the matrix document to say, here is the way we should run programs digitally. Here's what right looks like for the program. But in future, we can't say our way of training is going to be the Jason Bartolomews who go out and train themselves. We have to provide this steady state, and that's part of why AFMC is kicking off the digital campaign. I will turn over to General Bunch for an aside, but I'm going to imagine that he will tell you that getting people trained is the first and foremost important thing, because without them, you can't do the other technical aspects. General Bunch?
Yeah, so Dr. Roper, thanks again for being with us, and thanks for your passion on this. You're exactly right. The foundation that all this is built upon is our airmen, and we've got to get them trained. When Mr. Fisher gets into his new role as EN, it's going to be one of the first things Tom gets to go work is how do we make this reality for all of our engineering workforce. But it's not just the engineering workforce, it's all the workforce to make sure they understand how to do this so that they can contribute to the vision that you've set going forward, and that we can move out and reap those benefits that you captured in your words.
Yep, so this is one that General Bunch and I will share. We both are passionate about it, and we want to do this at scale. You know, I can work one program at a time, but we really want to do this at scale and across all life cycle facets. So we're talking engineering, but we've seen on programs with these tools, it speeds up contracting, it speeds up negotiation timelines. You know, it speeds up everything. We haven't seen anything that slows down, and everything speeds up. So I imagine that every functional is going to have unique training that's not just reading a couple of white pages. They're going to have to learn how to use these tools to change the way they do business. And so, you know, we're going to have to run this three-legged race together to get to the goal line.
And we're ready to run that with you, Dr. Roper. You're exactly right. It cuts across everything. Even my old community of test will have to have quite a bit going in that area, because it should fundamentally change the way we do it. I like the words you used. We'll have to demonstrate it, but it should tie back into it and be able to reduce the amount of testing and get us to the field quicker.
Copy that, General. That's just one of the reasons why we acknowledge that we built a full-scale flight demonstrator. We didn't do NGAD fully digital, but boy, we went quickly. But we still needed to go get real-world data. But why do we want that real-world data? Why do we want the test enterprise to work quickly with us? Is that we want to go back and make our digital model, our digital thread, as good as it can be. So and I've seen that in our testing teams, that they get it, right? That we're all about making that digital thing as close to reality as possible. And once it's reality for us, or effectively reality, that it opens the door to doing amazing things. So we've had a lot of great people across these few programs really learn how to change their jobs. And now it's time to make this the rule and no longer the exception.
Thank you, gentlemen. Actually, the next highest question was related to culture, and I think both of you have been sort of talking to that in terms of how we're going to get this done. Let me just end on one final question, Dr. Roper. I want to be respectful of the time and everybody else's who's seen the agenda. The last question is really, you know, how soon, you know, can we expect to actually start getting hands-on engineering test data flowing from the key sources within supply chain and the DIB? To adequately start fueling this change in the enterprise?
It really will happen one new program by one new program. I think there will be some hope that aside from full systems, that we will be able to do this on subsystems and not have to wait for the fully integrated system. I'll give you an example. If we're going to be doing installation of subsystems on the VC-25B, well, we're not talking about a huge number of aircraft in this case, so can we afford to to digitize the components that are analog, namely the airframe, so that we can change how quickly we do assembly and maintenance? Absolutely. That would be different than designing digitally from the ground up. But I think there are two things that I'll be expecting. Every new program, every from scratch program adopts full digital threading unless it's a UON or there's some reason that we cannot do those steps. So for you in industry, step one for you will be effectively a digital competition. So, you know, you get put on contract, we make our government tech stack available to you, you get all the automation, you move whatever you've done prior to award in, and off you go. And depending on the nature of the program, we may take you up to something short of a full e-system design, or we may take you all the way, where you design a fully integrated digital system. It may not be anchored. We may still decide we need to build a physical one, but we've at least exercised your digital engineering chops and felt like we've reduced a lot of the design and integration risk, even if we need to go get some test or data otherwise. So that should be true from here on out for new programs. That will slowly start making our enterprise digital. For modernization or upgrade programs, I'm looking to every program team to fight for as much digitization as they can bring in. We haven't had a program do this. The B-52 commercial engine replacement program is certainly using a lot of digital engineering on a system that is very much analog, built long before most of the airmen who are working on that program have been in the force. So there's a whole playbook to write on how you bring the best of digital engineering into a legacy system. And to be frank, I don't have my thoughts together on that. I haven't seen enough examples of it. So I ask industry, join the team on this. You know the systems that you support. Tell us your ideas on this. What I've seen in T7 and NGAD GBSD is just killing off the things in the hopefully humorous matrix document that I call those Agent Smiths of acquisition. You know, the bad guys that come and ruin everything, like learning curve and concurrency and integration risk. We've all had those things thrown out in a meeting, an acquisition meeting, and they make everyone go, oh, clearly that must have been the curveball that pulled the program off the rails. Well, it doesn't have to be digitally. In fact, concurrency can actually be your friend. If you've got your tools right, concurrency is something you want because you can deal with it. So I see the benefit of that from the programs I've mentioned, but we haven't seen the amazing examples yet from legacy systems. So I'm interested in that. And I'm also interested in going to places we haven't been. I only have 2 programs working on satellites, ESATs, trying to see if we can bring the same methodology, but it's going to take some time. I mean, aviation's been moving this way for longer than satellites, so it'll take time. I guess GBSD is technically a weapon, but I'd like to see this applied for tactical weapons. Again, simplify assembly and try to speed up the ability to do modernization. So bottom line, if you're there in industry, we're going to be really open and transparent. General Bunch and I are going to keep comms open across our entire workforce. Every new program is probably going to change my view of the direction programs are going to go. And then I'm sure I'm going to hear back from General Bunch as he works on the training and the manning and equipping, which parts of the workforce are ready to go with fully digital and which parts, there's still work to do. And we'll make those two things try to meet in the middle and make as many of these programs digitally excellent as we possibly can.
All right, terrific. I double checked. We have just about 3 minutes left. Here's one that we know is a very, I don't know if I should say hot button issue of great interest to our industry colleagues, and that's about IP rights. Their intellectual proprietary data. How do companies maintain IP rights as we move forward into this future you're describing? Over.
Great. It should get a lot easier. Also, the government has not been great on this one. I know we've made IP a bad word in government, but what I've seen in the just few programs that are radically digital is that it becomes crystal clear where the government needs to have government purpose or government ownership, and where we can just turn it over to industry to put the best that you can bring in terms of IP. And all we're really looking to do is ensure that we can continue modernizing systems if we need to. It's the interfaces, it's the things that turn programs into ecosystems for future competition. And I know when you're the prime, that may be not what you don't want, but when you're not the prime, the ability to access that ecosystem hopefully is a stabilizing option for more cash flow and revenue outside of the lockdown approach we do today. Without those digital engineering tools, it's a little harder for a government team to look at a complicated design and know exactly where they need to control IP and where they don't need to. I think that puts us in a default mode where we don't want IP anywhere. And my goal for the U.S. Air Force and Space Force is that we are the most pro IP service of all. But where it benefits the warfighter is also where it should benefit you. And as long as you've got the best thing that goes in that spot and no one's knocked you off the top, then you should be able to stay and continue reaping the benefit of your investment. And I think that without that insight on the government part, we made IP a pejorative term, and that's put industry in a tougher predicament. So to end, these digital engineering tools make everything a little easier. It lets you have a frank, technical, numbers-based discussion between the government and industry. And I think getting to that point where the technical people can come back with courses of action so that the business developer or program manager types can find a way to square the circle is going to help us get to the goal line faster. And I have watched that in negotiations, like unprecedented meeting of the minds and coming to closure, because the digital tools went from so many considerations that 1,000 people couldn't have wrestled with them to 4 or 5 areas that were the only places that you had to bring the government industry together. And I expect that trend to continue. It's another reason we want to share the same tech stack, or at least the government reference architecture. We need to see your system the same way you do. And the more that we do, the more common our language will be.
All right, outstanding. So the next thing on the agenda is the GBSD update. But before we go to that, since we have both of you gentlemen, any closing thoughts and comments as we move into this next phase? Let me just start with General Bunch, if we can switch the camera over. General Bunch, any thoughts that you'd like to share?
No, Bill, I encourage, as Dr. Roper said, we know that we need to listen, so we want your feedback. We want your questions. We want to be able to explain where we're trying to go. And we want to hear about your experiences. So that's the big thing today. It should be a dialogue. It should be an exchange. And we are in the early stages of this, and we're trying to drive it, but we want to get there quicker. The last one for me is Dr. Roper, thanks for your time today. I really appreciate you opening up and sharing the vision so that everybody can understand where we're trying to push and the value. I think you and I both are passionate about this. I think we both see the great benefit of this, and we got to work together to make it happen. So thank you for your time today.
General Bunch, my pleasure. The only thing I would ask for industry is you are talking with your leadership, and also if you're talking with members in the department that are senior leaders on the Hill, make sure when you're talking about your program, you talk about the IT that's needed to support it. We've had a very difficult time justifying IT historically, and it's a warfighting system. And we're talking about developing and testing. The same tech stack that we're using to develop systems is the same one we just demonstrated at the ABMS on-ramp a few weeks ago to shoot down a cruise missile. We're going to be using the same tech stack to go from development all the way to actually doing battlefield operations. It's a challenge to do that, but IT just became a warfighting system, and if we don't start treating it like one, then we're kidding ourselves. So I think if you could help us with just the community as a whole to say that if you really care about System X, you need to care about the IT that supports it. And if we've got the right IT, that I would imagine in General Bunch's shoes that if you could actually log into the tools we want you to use across our enterprise, it's going to make the training a lot easier to do when you can see what you're training on. And then the sooner we get that, the sooner I'll be able to start playing around with programs and trying to get the best lessons learned out. And General Bunch and I will stay in lockstep on programs like T7, GBSD, NGAD, B52 SERP, so that we're passing along best lessons learned. And NGAD, there's still some more things that we can get outside of the classified. You know, we don't want to classify how we build things. Like the process is commercial, right? So the worst thing the Defense Department could do would be to start treating using a commercial process as somehow different from the things we're building with it. And so I think there are more lessons learned we can share. GBSD is obviously a very classified program. We've worked hard to get its lessons learned on the outside. And so I commit to you to share how we're building things. What we're building, we're going to have to treat as business as usual.
Okay, thank you very much, Dr. Roper, General Bunch. We're now going to shift to the expert in GBSD program. Colonel Jason Bartholome is going to tell us, give us a quick brief and some of the insights that they've learned from the digital engineering experience for a program in the early stages, but a program that would be hard to overstate in terms of its complexity. So with that, Colonel Bartholome, over to you.
Hey, thanks, sir. And thank you, General Bunch and Dr. Roper, for all your support. We wouldn't be where we are today in GBSD without your leadership. And we find this to be just a terribly exciting time. We believe that we're really at an inflection point for digital engineering and systems engineering. And as I go through my slides, I just want to share that we've been on a multi-year odyssey, really about 6 years, doing all the things that I'm going to share with you today. And it's been a difficult and exciting time, and really bringing the engineers together along with the acquisition managers and the sustainers. What we're finding is that digital engineering is not just for the engineers, but for the entire enterprise. And really, the chief's quote on accelerating change or lose, I thought I'd start my presentation just sharing with you that our digital engineering odyssey has really been born out of necessity. To deliver a weapon system as big and as important as GBSD with time-certain delivery is a huge challenge. And quite frankly, I don't see a pathway to do it without actually accelerating the change in this domain. And if we could go to the next chart, sir, just to give everyone who's not familiar with GBSD, I've got a diagram that just shows you the land-based leg of the triad, and really wanted to focus your attention on the 3 missile wings. And just to give you a sense of the size, scale, and complexity, we operate, today 3 missile wings with over 150 missile silos. That's just a living and breathing system that is to deter the adversary from attacking us, as well as our missiles are on alert to hold adversary targets at risk. And if you look at each one of those missile wings, each one of them is the size of a mid-Atlantic state. So if you think about the state of Connecticut or the state of New Jersey or the state of Delaware, our missile fields are living weapon systems that are the size of a state. And so just the size and the scale is really breathtaking. Once we start replacing Minuteman III and replacing them with GBSD sorties, that'll happen once a week for 9 years. And when you look at the weapon system under the hood, you see a complex C2 architecture. You have an airplane or multiple airplanes. You have an exquisite strategic missile with some of the most exquisite technology that we deploy in the entire Air Force to hold targets at risk. And so really, the weapon system in terms of its size and scale is truly breathtaking. And we call it a mega project of epic proportions. So as I go in and brief you on what we've been learning on digital engineering, I think it's important just to see the size and the scale of the system that we are pursuing, and really all of the elements that Dr. Roper described, the digital twin, the digital thread, the tech stack, are all things that we believe is our best and safest path to deliver this weapon system, and very, very encouraged to see all of the energy behind it. If you go to the next chart here, One of the documents that we have found useful, and I'll use to frame my comments today, is the OSD's digital engineering strategy that was published in 2018. And really, that document and Dr. Roper's new document, Take the Red Pill, the new age of digital acquisition reality, that was been referenced in the briefings today. Those two documents are extremely valuable and useful to get you started in thinking about digital engineering. And as I go through the presentation today, I'll really focus on these 5 dimensions: how we've been using models to formalize our enterprise and program decision making. 2 is to provide enduring authoritative source of truth and what that's meant for us so far. To incorporate technical innovation to improve engineering practice. To support, establish supporting infrastructure, and then to transform the culture in the workforce. And we'll give you all a quick update on where we stand along those things, and looking forward to partnering with everybody as we go forward. Next chart, please. So in the arena of formalizing the development, integration, use of models to inform decision making, we started 6 years ago with developing a government reference architecture that we use to communicate to industry. And this is, I think, a really strong point for those that are looking for lessons learned, is redefining what it is that the engineers and the technologists and the warfighter provides industry. Really, for GBSD, having a government reference architecture that we own and we presented has been incredibly useful, not only in helping us understand what it is that we need to deliver for the warfighter, but as a powerful instrument of communicating those needs to industry. And at SFR, we had developed a government reference architecture that had over 500,000 elements. It had all of the relevant views that you might find in a DODAF, and we found it to be a very powerful way of communicating what we want to buy. And as a part of what we have agreed to with our industry partners is that they deliver back to us a weapon system architecture model that basically it builds the leaves, the branches and the leaves of the tree of the base trunk of our model that we present to them. And so over the course of the TMRR phase at GBSD, we had been trading those models back and forth with our industry partners. And at our PDR, we had delivered a weapon system architecture model that described all elements of the weapon system electronically, that's searchable, with over 3 million elements. And just to give you a sense of future design reviews, my first deep dive into the primes model was a 6-hour deep dive that had only 3 slides, and the rest of the time was spent navigating the engineering model. And we were able to map the system and see their solution from message receipt in the ICBM to weapon delivery. And we were able to navigate together through their design, which was incredibly powerful. In addition, we've been working very hard to actually broaden the modeling capabilities to not only include engineering models, but also cost models. And in the lower left, you see one of our cost capability diagrams that came really early on in the program. And what you're looking at there is a trade space analysis where each blue dot is a different outer mold line for our booster. And in that diagram right there, you see almost 1,000 different booster designs. And really what we were working on with our MAGCOM partners and industry was trying to understand which requirements were actually driving cost and schedule risk before we decided to choose a particular solution. And we not only did this for the booster design, but we actually did this for really every requirement in the CDD. And on the government team, because we had the digital engineering environment, we were able to analyze using heuristic optimization over 6 billion system designs on the government side of the firewall. And we were able to compare those designs and that trade space against what it was that our industry partners were providing. And we were very happy that our industry partners also did the exact same cost capability analysis. It was required by contract, and we were able to look and see what requirements were driving cost and schedule risk into the system early on. The last thing I'd say is that we're always interested in visualization. We're talking about very high dimension dimensionality and hyperspace types of trade spaces. And so the ability to visualize and see the weapon system in new ways is something that we've been working on quite a bit, and something that we're very interested in going in the future. If you go to the next chart, the next section is providing an authoritative source of truth. I thought Dr. Roper did a wonderful job of explaining the idea of a digital thread and digital twin. Right now, we are on a path to produce a digital twin for every launch facility, and we believe every missile and the C2 network going forward. For this particular system, because we're using the same launch facilities that are currently being operated by Minuteman III, we're able to actually get a head start on that. And if you came to visit our sandbox, you'd see a wonderful display of over 40,000 drawings rendered digitally, and we're able to fly through a launch facility. And then even better, we've been taking panel data sets and time series data sets of maintenance data and geospatial data about the Minuteman III, and we've been bringing the digital twin into time and space. And the opportunities for maintenance and sustainment have been incredibly insightful. In addition to not only maintenance and sustainment, we're already looking at ways to look at this from a safe and secure perspective in operating the system in the future. And what's so exciting from where we stand is that we really are in control of our data future in ways that really are opening our eyes to possibilities. And so we describe GBSD as being a machine learning and AI-friendly weapon system on a few dimensions. This is one of the key areas where we see advanced analytics, machine learning, and artificial intelligence already helping us as we prepare for the transition of the weapon system. Next chart. In addition to that, we find we're also sort of at an inflection point where digital engineering has brought the operational and intelligence communities much closer to GBSD in ways that I haven't seen before. Each year now we host an intelligence summit. We actually now co-chair it with the Navy, where we bring the operational communities and the intelligence communities thinking about strategic systems together. And what we did early on is we started mapping where the adversary's threats are actually stressing the weapon system to identify the hotspots and the key interfaces that we need to pay particular attention to in the design. And that helped guide our modular and open mission system approach for the weapon system. And not only are we believe a artificial intelligence and machine learning friendly weapon system, but we also believe that we're an innovation-friendly weapon system because we are lowering the barriers to be able to help modernize the weapon system over time. We've established an advanced planning construct, and I think one of the advantages of digital engineering, now that we have the artifacts and the interfaces, we're able to communicate more broadly about the key technologies that we're going to need to bring onto the weapon system over time. And so we look forward to working with our mission partners, both in industry and in the operational intelligence communities, as we look forward to modernizing this weapon system to 2075. Next chart. And then almost lastly, we mentioned in the previous discussions with Dr. Roper just the importance of the infrastructure, the IT-based infrastructure that we need to actually accomplish this mission. We are moving headlong into the cloud infrastructure, not only for digital engineering, but also for our DevSec and DevStarOps. So we have developed a GFE container-based software factory for GBSD that we're working very closely with our industry partners. And we are all in on Platform One to not only execute this program within GBSD, but also to share with other mission partners and other programs outside of the GBSD program office. We see lots of advantages. One is we think there will be a wonderful environment to be able to share the capabilities that are going to be coming online in this arena, but also it's very helpful for us because we're able to now distribute our PMO, our program office capability beyond just Hill Air Force Base. Now we have operating locations in a number of locations across the U.S., ranging from Boston to DC to Southern California to Alabama. And so we see this as a huge enabler for accomplishing what we need to accomplish for the future of this weapon system. Next chart. And then lastly, is really about transforming the culture and the workforce. There's really an exciting future. I've found that in some respects, many of these things seem to be quite intimidating, but when the engineers and the great professionals actually dive in, I believe the barrier to actually make great progress is much lower than people perceive. Again, we've been at this for 6 years. We've learned a lot of lessons. I think that a lot of the lessons that we've learned as a program, we've already begun to share with other organizations. And I think that hitting the knee in the curve for those both in industry and other programs is much closer than you might expect. We're very interested in folks that are maybe this presentation inspires you to work on the ICBM or GBSD. I'd love to hear from folks online that would love to be a part of our team. You can catch me at jason.bartolome@us.af.mil. We're also super interested to work with our mission partners and industry partners. And so if there are any folks that have any great ideas based on the limited things I was able to share, by all means, please send me an email, and we look forward to reach out and connect with you. And lastly, General Cooley and the folks on the task force, we're standing by to help other programs get up and running, because really to meet the chief's vision to accelerate change or lose, we want to help bring the future faster for the other teams. So, sir, I'll stand by for any questions. I'm over.
Hey, fantastic. Thanks, Colonel Bartolome. Great job, as usual, to sort of set the stage. So just an administrative comment. We've posted a number of things in the Q&A. We didn't have time to get through all of those, but we're trying to answer those separately. And so there'll be follow-up. I'm getting the rest of the team on that. So the next talk is from Eglin, really what we sometimes call Team Eglin. The folks down there, the PEO, the labs, the test range, really the weapons center brains for the Air Force. They're leaning into this heavily. And so Dr. Craig Ewing, who's the lead for AFRL and the modeling simulation capabilities down there, is going to give you an update on what he's called Weapons One. So Dr. Ewing, over to you, sir.
Great. Thank you very much, General Cooley. So I wanted to give you a quick overview of what we're doing down at Eglin through the Weapons Enterprise for Weapon One. If you can go to the next chart, please. So Weapon One came about, it's fairly young in its life cycle. We've only been working on it since past December, so less than 9 months with COVID in the middle. So I'm very enthusiastic and impressed by how far we've been able to come in trying to transform the entire weapons digital enterprise at Eglin with the laboratory, the SPOs, and the test wing all participating in how we establish the digital engineering aspect across the life cycle. So if you go to the next chart for me. So if you wanted to look at Weapon One as an all-in-one chart, we are trying to establish the weapons enterprise, digital, agile, and open ecosystem for, as Dr. Roper said, tactical weapons. So we are starting all the way from inputting warfighter needs and into our model-based systems engineering tools currently using Cameo, and integrating that MBSE with our modeling and simulation capabilities to be able to and to be able to use what I know it just says R1 on this chart, but it stands for Rogue One. If you can't read that, that's very tiny. But utilizing our DevSecOps process Rogue One to be able to integrate emerging technologies much more quickly in tactical weapons. So while we're doing that, we are actually also working in the digital twin arena, trying to figure out how we will take digital twin prototypes across the acquisition life cycle, and then eventually they'll become a real digital twin when you're manufacturing an actual weapon product. We are excited about trying to make sure we are tying our government reference architecture also to be compatible with ABMS, as we would like to be able to see ABMS used both as a user and as a supplier of data from weapons. So we can bring weapon sensor technology into the ABMS sensor web, as well as we could use ABMS data that we can collect either in flight or after missions to flow through digital twins and improve the next swarm of weapons, even improve the swarm of weapons in flight using edge computing. So we're designing those systems with a weapon open systems architecture in mind, the desire of using AI/ML techniques and to be able to change software quickly, as well as be able to change technology quickly on weapons, so that we have a constant tech refresh. One of the things that is interesting for Weapon 1 is we are looking at it all the way across the acquisition lifecycle. So we are starting from the very beginning, before concepts have even been thought of, trying to look at how we take that through manufacturing and eventually into even sustainment, logistics and sustainment at the end. We have 3 major products, and I'll go over those a little further in a couple charts, but we are developing government reference architecture for weapons, as well as authoritative source of truth, which will be for a lot of different programs that are going on down here at Eglin. And we're working on developing that digital twin and taking the digital thread throughout the acquisition lifecycle. We are partnered with our users across the entire weapons digital enterprise. So from all the way at the very beginning of requirements and gap planning for warfighters, through doing technology R&D in the lab, eventually engineering and acquisition at the SPOs, and then project management and operations analysis through the testing and training. And I'll show you a little more on that in the future. Next chart, please. So to do that, as Dr. Roper was stating, we are building our tech stack as well. At the infrastructure level, we are onboarded with Cloud One and Fences. We also have we're taking kind of a multi-hybrid cloud approach right now, and also including a Secret Vision network, which is an AFRL network that'll allow us to work locally on the base while we further onboard with Cloud One and Platform One for cloud-based services. We are developing our DevSecOps pipeline using Platform One and Big Bang Git repo so that we can do that automation that was talked about by Dr. Roper. We are working actively on integrating our MBSE tool Cameo with our modeling and sim tools like AFSIM and Storm and our physics-based tools. We are really integrating that entire modeling and sim pyramid, from physics to engagement to mission to campaign and wargaming, all with our MBSE tools, so that we can evaluate return on investment on different concepts and then use that software stack as we flow through the acquisition lifecycle, and all those models will go along with it. Next chart, please. So in our model-based systems engineering, we are taking concept guidance and doctrine. We are programming into our MBSE tool mission threads for the Air Force in global precision attack, as well as air superiority, so we can identify where there are gaps and needs from the doctrine and the guidance, generating those mission thread storyboards that feed over to our modeling and sim teams, where they can analyze performance and return on investment for those ideas and concepts. And as we're doing that, we're actually developing the very first prototypes for our digital twins that will flow through the acquisition cycle and become actual digital twins when there are physical twins, physical entities available. Next chart, please. So as I said, our digital twin lifecycle starts off very early, sometimes as just a 3 degree of freedom simulation when we're just looking at conceptual ideas. Eventually, as we build further and the return on investment looks good for different concepts, you can start to add more fidelity to that virtual prototype and with 6 degree of freedom simulations, or incorporate more from the weapon open system architecture, bring in higher fidelity physics-based sims. And as you do that, we are building our digital twin prototype to be higher and higher fidelity. And eventually, we're going to have to learn how to work with our acquisition community to take on a new role, which is certifying a weapon digital twin, which is something, in some aspects, we've done that before because AFCEO always certifies safe separation from aircraft and things like that. But now you're going to be certifying an entire weapon digital twin capability for use. As was stated earlier, we like to be able to reduce testing and evaluation by offering, augmenting it with digital twin capabilities, looking at predictive maintenance out in the sustainment world, or ops reprogramming during operations, as well as inserting tech refresh. So the digital twin has quite a capability to go through the entire life cycle. Next chart, please. One of the things that we are developing is a government reference architecture for munitions. It is incorporates weapon open system architecture as part of it. Our current GRA for collaborative weapons has about 25,000 elements in it, and we are anticipating being able to bring that first GRA for weapons out to the community, perhaps a rough draft of it in November, and then our first release in January, so that we can all start getting on board with what the industry guys are doing for their reference architectures, and starting to match those two up together. Because as Jason was saying as well, and many people have said already today, we have to figure out that way to integrate all the industry digital engineering architectures with the government one as well. Next chart, please. As far as our authoritative source of truth, we are also trying to work. We're onboarded with Cloud One. We anticipate using that as part of our federated digital thread. We don't envision necessarily that all data is stored in one single place, but instead that you have the capability of being able to access that data wherever it is stored. But cloud-based repository Cloud One is what we're aiming to use right now. We're on MITRE Deep Nerve for our authoritative source of truth for collaborative weapons. And we are also investigating AI and ML smart search and retrieval techniques for how you can go out and find the data you need, whether you are in the lab or you're a cost guy or a trainer or you're an operations person. There are different needs for different data, and you have to be able to find it quickly. Next chart. And just a couple quick mentions of what we're using Weapon One for currently at Eglin. We have created a digital engineering enabled live virtual constructive weapons testbed that we're working on right now to take all the different resources that are available, both digital engineering as well as test resources. So you can kind of see in that circle there, you have the laboratory, the SPOs. So the laboratory has some live virtual constructive facilities. It has hardware-in-a-loop facilities and lethality capabilities. The SPOs have the Death Star and their modeling and sim and AOAs. The range, the 96 Test Wing has the GWEF for hardware-in-a-loop, as well as the range and the primes facilities. And the 53rd has the operations and sustainment and support. So trying to put all that together, centered around the ASOT, using the architectures that we talked about, like Cloud One, Fences, and Secret Vision, to connect all that together. Coming up here in October, we're actually going to be demonstrating a digital twin enabled operations software upgrade, where we'll be using software variants of a collaborative weapon flying out in a swarm mission, encountering some issues along the way that it did not expect, and collecting that data back over through an ABMS cyber assured cloud to then feed a digital twin model using some AI/ML techniques to ascertain where we might put either some different playbooks or a software improvement into the weapon system for the next set of flight for that weapon that's coming out. And so we'll be demonstrating that in October, and we're also trying to figure out a way that we can get industry invited to that event, so that if it turns out it's too difficult, we'll at least record it and let everybody have access to that. We're applying the Weapon One digital engineering to network collaborative weapons right now for LCCM and Grey Wolf. It's also being used for the Golden Horde Vanguard and for hypersonics for HACM. We've been working on contractual language as well as proposing using this LVC test bed for Navy MES JADC2 on-ramp. Next chart. And just lastly, for the way forward, so as has been stated by all of the people so far I've spoke, we are really very, very interested in figuring out how to integrate and interoperate with industry. We have already had several interactions with several partners, and we're going to establish a biannual industry council where people from the weapons community can come in and we can talk about digital engineering and figure out how we can integrate the best. We're also really interested in people with ideas on AI/ML techniques for leveraging the data, and we're working right now to expand our weapons enterprise to include things that are further out in the acquisition life cycle, such as manufacturing cost and sustainment and training. So I think I can stop right there.
Thank you very much, Dr. Ewing. No, terrific presentation and update on your progress for the weapons community. All right, our final exemplar program is from the MILSATCOM program office, the Protected Anti-Jam Tactical SATCOM. Mr. Fu Tran is going to be providing the briefing. Let me just say, as an old MILSATCOM guy myself, I spent some time, and the architecture is extremely complex and challenging, and yet the backbone of much of our communication. The team out there has done just a terrific job of building out that architecture and defining it in ways that help not just the engineering community understand the details, but also the operational community understand the details, such that we can have visibility on the impact of message set changes and other standard modifications throughout the entire architecture. So I'm really excited to hear this briefing, and have been very impressed with the work that the team has accomplished out there at SMC and the MILSATCOM program office in particular. So with that, let me turn it over to Fu Tran, sir.
General Curley, sir, thank you so much for the warm introduction. Good morning, ladies and gentlemen. My name is Phil Tran. I support the Protected Anti-Jam Tactical SATCOM PAT program office here at Space and Missile Systems Center, SMC Development Corps Tactical SATCOM Division. I'm here to provide a quick overview of our past mission area, our current digital engineering activities, and our plans for next year within the Space Force SMC digital engineering ecosystem. Next chart, please. All right, for those of you who's not familiar with PATS, here's a quick overview of our mission area. PATS is a system of systems that provides protected tactical SATCOM to our warfighter in both contested and benign environments. PATS is not a program of record. It's the umbrella capability of all the systems used to support the protected tactical waveform, the PTW, within the DoD, including the Protected Tactical Enterprise Service, PTES, our ground segment, the Protected Tactical SATCOM, PTS, our purpose-built space segment, a joint effort between Air Force and Army for the terminal modem segment called Air Force Army Anti-Jam Modem, A3M, and a Navy effort called Wideband Anti-Jam Modem System, WAMS, down in Napa, San Diego. We also support ABMS in their Radio 1, F-35 JPO, and the 5th Gen Open Radio Architecture, COCOMs, and international partners as the future tactical SATCOM capability for coalition ops. PATS will be implemented in 3 phases, aligning with ground capability, including a phase of PTES to provide PTW over WGS, The commercial phase increased flexibility and resiliency by supporting PTW over ComSatCom, and the PTS phase, the capstone of PATS, adds PTW over a fully processed payload for near-peer jamming protection. Our acquisition team has done a tremendous job of expanding the industrial base. We have 3 vendors competitively developing the space segments, 4 parallel modem lineup efforts, and 1 enterprise crown, and taking advantages of the Section 804 rapid prototyping, implementing DevSecOps, open architecture, microservices, and service mesh for authentication and authorization for ground software. We also include the traditional waterfall system engineering process for our hardware modem and our NSA cryptos. As you can see in this construct, if you draw 2 vertical lines down the chart, it will show 3 faces of PATS. If you then draw 2 horizontal lines, it will show the 3 segments of PATS. All 9 pieces of this puzzle are independently managed by their own programs. Government here is the true integrator, and we have to manage and pull all the data across all the programs and stakeholders to integrate. We quickly found out it's a very complex task. How to handle agile process where they implement MVPs and continue to thicken the thread while the other segments actually need this information to build their parts. How do we evaluate when it's good enough? We have requirement from NSA on our crypto development. We are not allowed to take the crypto out of their secure development environment until they are fully certified. How do we ensure interoperability? How do we ensure system integration and reduce the system integration risk? Everything that I mentioned were basically the genesis that led to our digital engineering journey. Next chart, please. So for the last 4 years, we have invested and developed our digital inventory. We have a very robust government reference architecture, GRA, both static and dynamic models for all programs to follow. We were able to produce TRDs and ICD directly from the model to support program resolicitation and RP activities. Our bidder, were able to receive both set of documents and models as a package to support their proposal development. Next chart, please. So PATS is a communication system. Our main purpose is to deliver comms from A to B, and it's that plain and simple, but the implementation is extremely complex. Every link in that end-to-end chain of variables in the equation. We have 30 different modes in our waveform to operate based on the available resources and operating environments. 100 different variant types of terminal from Air Force ground, Air Force airborne, Army ground, Army mobile platforms, Navy surface ship, Navy sub, Navy shore, and even Navy airborne. 2 different network architectures, class of service for most and PPPoE for Navy. 3 satellite constellation, as I mentioned earlier, PTW over existing WGS constellation, PTW over commercial satellites, and PTW over our own purpose-built PTS. Our digital engineering capability were designed to manage these complexity. So if you can see from this chart, starting from right to left, we have emulators, simulators that represent an end-to-end capability of our system. With hardware in the loop, we can demonstrate over-the-air comms today without involving any parts of the ongoing operational programs. We can go out and get real-world data to further improve and refine our technical baseline and our MSNA tools. We have conducting risk reduction activity to understand on how our next phase will look like, on how our system and architecture will look like and perform on different orbits. With the recent accomplishment during the COVID-19, our international partner from the UK came to us and ignited a plan to conduct a demo, really put in our waveform and emulators over the UK Skynet Spy Charlie constellation. We were able to pull everything together quickly, execute a full end-to-end test with them, and demonstrate the feasibility and the flexibility of our system over their own satellite and cement their buy-in for the mission area. Next is basically we have MATLAB models, MSNA tools to conduct performance analysis of our waveform, link budget, and antenna assessment. We can predict exactly how a terminal will perform with our system based on the specs. We have MBSE GRA models for every program, PTES, PTS, A3M, and currently are working on the overarching PATS model Our ground program, P-Test, they are implementing agile software development. We also have their current as-built model in our repository. We have a digital twin of our ground segment program, the virtual PATSOC, to use as a communication tool between program office and future operators. However, and this is the area where we can further improve, all of these tools and artifacts as shown here currently are not fully integrated or even co-located. Some are hosted by our FFRDCs at MIT Link Lab in Boston, at Aerospace in Los Angeles. Some are hosted on DI2E, and some are hosted on our SE&I contractor AWS cloud environment. We are making every effort to synchronize them, but it's still very difficult to track, synchronize, and manage them all at this point. Next chart, please. So for the next couple months and perhaps the entire fiscal year 21, we plan to take our implementations a step further. We do believe we have all the pieces of the puzzle together. As Dr. Roper mentions, our system and our architecture are open and modular. Our waveform is frequency agnostic and can operate over any pen pipe systems. We own the technical baseline, the GRA and all the ICDs between and among all the system and segments. Cybersecurity is baked in end-to-end and from ground up. We own data rights where they are critical to the system, all the interfaces, and where applicable to the program phase of acquisition. Collaborating with the Space Force digital engineering ecosystem, we can expand beyond the technical baseline actually to own the technical stack. We plan to integrate and curate all the digital artifacts that we have now and actually enable them into a true ecosystem where we can apply it across all the disciplines functions, the program management, the system engineering, integration and test, and stakeholder integration to support all program lifecycle activities. And not only that, we plan to ingest our contractor as-built artifact into this ecosystem where it become a one-stop shop where any user, any stakeholder can have access to the latest and greatest technical baseline, MBSE GRA models, MATLAB models, emulators, simulators, and even a copy of our real ground mission management system. We will apply configuration management across them all, define authoritative source of truth, and slowly transition away from paper products. In the upcoming year of 21, we have a major system integration event that we would like to execute directly from this concept and digital engineering ecosystem. This will be the first time our ground and the terminal modems coming together to conduct system integration. We are leading and running this event as a true government system integrator. We are currently developing test architectures, test diagrams, test cases, and test procedures directly on Smart EA. And for the event execution, we would like to be able just to pull up a web portal, log into our DEE, and execute a test readiness review, the TRR, and the whole test event directly from there. Capturing test result directly to the DEE, conducting post-test analysis directly on the DEE, and producing test report directly from the tool. No longer do we have to develop everything on paper and hand jam them in the tool as an afterthought. We would like to flip the script and turn the info contained in the DEE as the authoritative source of truth. We do believe we're almost there. We have plans and processes to make this vision a reality. Will we succeed? I don't know, but I'm sure we will learn. I'm sure we will learn a whole lot between now and then. Sir, with that, it concludes my portion of the brief. Back over to you, sir.
Okay, fantastic. Now, you did a great job, but you forgot to turn on your camera so we could see see your background in Los Angeles and everything. That's okay. We'll get you next time. Hey, no, thanks. Terrific brief. All right, so we are running just a couple of minutes. It looks like a minute or so behind. What we'd like to do now is take a 10-minute break and reconvene at 13:25 Eastern Standard Time. So that's about maybe 9 minutes from now. So if everybody wants to take a short bio break or stretch your legs, that'd be terrific. When you come back, we will. I'll present some of the things we're doing relative to the digital campaign and get into some of the details. So with that, we're continuing to process through questions and please be patient with us. We're working through those so that we can hopefully answer as many of those as possible. So keep them coming and keep voting on them. That's the criteria we will use. And with that, please, 10-minute break. Okay, everybody, it's been approximately 10 minutes. What I'd like to do now is continue with the second half of our presentation and go through some of the specific details of what it is we're attempting to do to enable this across the enterprise. As you can see, this says it's the AFMC digital campaign, as General Bunch talked about. That's how we started. But we debated over the title. This is really an SMC. This is a Department of the Air Force. This is the entire ecosystem has to move out together. And you heard Dr. Roper and General Bunch are very much in lockstep on this. So we've arrayed it with 6 lines of effort. We're going to talk to you about those. I'm going to give you a quick overview of those. I'm going to then turn it over to hear from the Vice Commander out at SMC, General Cothern. And he'll give you his perspective on this, and then we're going to go into the details. So please go ahead and go to the next slide. So this is our vision. One team, one digital lifecycle enterprise. We know that it is a life cycle, all the way from the very beginning, early stages of envisioning what sort of performance a system would have in a campaign, and some of the modeling framework that's needed there, all the way to the sustainment end, where we're trying to do parts replacement and those kinds of activities, and covering all of the development, testing, everything in between. And so we're trying to take this as a life cycle and a life cycle view. You can see here's the list of some of the key elements that we believe are central to it. You'll see these reflected in the lines of effort. But clearly, we've had some discussion about the IT infrastructure, the collaborative ecosystem of models and tools. Many of the questions have been related to that. How do we do this across the government and industry? That's work ahead of us. We think there are ways to do that, but you'll hear from Mr. Mitch Miller and the data team, as well as and Mr. Tom Lockhart, who's really trying to wrestle that. The availability of data, this is an enormous challenge, and again, you've had many questions along those lines, and so we're trying to learn from models and examples that have worked well and build on that. The open architecture and standards, although it may not be obvious to many that this is part of what's going to make digital engineering successful, we absolutely believe it is, and so putting in place those architectures and standards is central. Again, you'll hear some about that. We believe there's also process changes that this will enable. If, as Dr. Roper said, if we just continue to do the same thing, only everything is digitized, then we really haven't gained much at all. We need to think about how we can move faster using authoritative sources of data. And then finally, that famous saying that many of us know, that culture eats strategy for lunch. We can have the best laid plan, but unless we can shift the culture and move our workforce and everything that we do and the way we think about things forward and into the 21st century, we're not going to succeed and really reap the benefits of this transformation. So those are the things that we know are in front of us. Please go ahead and go to the next slide. And so these are the specific goals for the digital campaign. I've touched on some of these, but let me go through them quickly. So, starting off with the workforce, we believe we've got to get a lot smarter about that, finding out what those skills are, not just in engineering, but across the all functionals to leverage that. The second bullet there, trade space exploration. This is something that we have done well in analysis of alternatives. But a lot of times, as a program moves forward in its life cycle, you lose lock on what the rational thinking was and what those trade space, that the analysis was that supported decisions. And so we want to make sure that we have an integrated system and understanding of to do the trade space and to continue to update it as we learn more, because we're always going to be smarter tomorrow. The third main bullet is moving things towards the cloud. We know that that's where the department needs to go. There are certainly efforts along those lines with Cloud One and others, and we are leveraging that heavily and learning from that. But in many cases, our infrastructure is not in place to completely support that, and so we're working that. You'll see some of that in our line of effort 0. We named it line of effort 0 because this is digital, and digital includes the number 0. Usually people think of zeros and ones. It also is foundational. That IT infrastructure, and I know that General Bunch talked about this last week in the AFA, how foundational IT infrastructure is. So we're working that, but we certainly see the long-term view of trying to move to the cloud. The fourth bullet there, I talked about data architectures and getting those authoritative sources of truth. Absolutely essential for everything that we do. Too often, many of our systems are stovepiped. Our organizations are stovepiped, but the systems are stovepiped, and we replicate data, and then we lose configuration control and lose lock on what's authoritative. We've got to do that, and that will also enable artificial intelligence to crunch on that with machine learning techniques and algorithms. The penultimate bullet is the reference architecture. You heard Dr. Roper talk about this. Clearly, that's important. You're going to hear more about this in upcoming slides with Mitch Miller. And then finally, those to transform processes to optimize what it is we're doing. Talked about this on the last slide, just that the updating our processes, and that's not just acquisition processes. That's to the intelligence, the test and evaluation, logistics, maintenance. We need to be willing and agile enough to think through how can we do things smarter and faster. So those are the broad sweeping goals. Next slide. I've kind of hinted at this, but here's the Rosetta Stone to map. You will hear some of the speakers talk about lines of effort, 1, 2, 3, and number them. This is how we have arrayed ourselves, and each of these is led by an SES or senior leader across the Air Force with a very capable team of leaders, senior folks, as well as PEO advisors on every one of these lines of effort. We have people from SMC and the space community on each of these. We have folks from the headquarters. So we're trying to reach out and make sure that as we move these forward and put in place the elements of each one of these, we have coordinated and collaborated across the entire enterprise, because this doesn't work unless we act and think like an enterprise. So you will hear from some of the key leaders here. Go ahead and go to the next slide. And I believe these are published. People have access to the slides, so you can follow up with emails or directly contacting these folks. These are some of the key leaders, or the champions, we're calling them, for each of those lines of effort. So if you want to follow up and get into detail on any one of these, those are the folks to start contacting with. And behind them, though, maybe the more important thing is behind them is a team of anywhere from, I'd say, about 40 to 70 subject matter experts who are engaged in helping figure out how we can move this enterprise forward. A lot of the questions I know for Dr. Roper were how are we going to do this? That's exactly what this team has been working on now for a little over 6 months to really try and get thoughtful answers to that. We haven't concluded. That's why we're having this exchange with industry, and to make sure that we're thinking about this right, and that we're doing so in light of the good things that industry can inform us on and move the enterprise forward smartly. Because if we don't include our industry partners with this, it's not going to work. But those are the folks to make contact with for each of the lines of effort. Go to the next slide, please. And with that, let me turn it over. If our technology and systems are working well, let me turn it over to Brigadier General Jason Cochran to speak from the Space Force perspective and the partnership that we've had at Space and Missile Systems Center. Sir, over to you.
Hey, General Cooley, we really appreciate the opportunity to speak here today. I think folks are aware, but the General Raymond, the Chief of Space Operations, has directed that the U.S. Space Force will be the first digital service. He's got several lines of effort with respect to that, to include digital ops, digital headquarters, digital workforce, and digital engineering. So this is near and dear to his heart, and our heart here at SMC. We've also taken Dr. Roper's Red Pill Challenge to heart, and we're engaged, we're leading, we're moving out in all of that direction. I think you heard from Dr. Tran earlier on our protected anti-jam tactical SATCOM. We also have other digital engineering flagship programs to include Space Combat Bus, Evolved Strategic Stratcom, and our portfolio architects, enterprise architecture and systems of systems engineering. Digital engineering within a collaborative digital ecosystem is critical to our future. I think that's clear and clear direction. And as General Cooley said, the teams have been moving out already. But it's more than just engineering and engineers, right? The whole workforce needs to be digitally fluent to be effective in facing the threats that we're going to face in future conflicts. This is required to field systems at the speed of relevance that our warfighters need to react to the threats, to implement innovation more quickly, and to provide those new technologies to maintain air and space superiority in the future. Our systems have become extraordinarily complex and diverse, and as they work together and they need to come together to complete our ever-changing missions in the future. So the Air Force Digital Campaign is essential, and it's going to help us provide the tools needed to manage across the enterprise. I love what you said, General Cooley. It is an enterprise. We got an air piece, we got a space piece, we got a cyber piece. It's all got to talk together in the enterprise, and this digital campaign, I think, is going to certainly help us get there. And it's going to allow our workforce to be prepared to make the change as we move in this direction. And as I said, it's the whole workforce that's got to be engaged and understand and be able to use the tools to enable our overall system to be more effective. I know some of our space systems, I know, General Cooley, you're well aware of GPS and how fundamental it is to our current way of life. But any changes to those systems now take months and maybe even years to implement due to the unknown consequences and the testing required to get us more comfortable as we try to implement those changes. You know, using models, authoritative data sources, digitally enhanced management, processes that will help reduce those that fear, that uncomfortableness, and ensure that we get these changes implemented significantly quicker. Finally, mission assurance, critical to our space business as space launches continues to be hard and dangerous, and it's got to be successful. So through the implementation of models and digital twins, that's going to allow our key decisions to be made with confidence as we move to approve launches, conduct on-orbit maneuvers, utilize our satellites in ways that not originally imagined to successfully complete the missions that our warfighters face today will face in the future in the ever-evolving threat environment. As you said, sir, you know, obviously SMC personnel have been supporting and been engaged in the Air Force Digital Campaign from the beginning. We'll continue working hand in hand with the Air Force as we move out on this important endeavor and continue to make progress on this important endeavor. We provided personnel to support all lines of effort, including many of our experts who've led efforts with nonprofit organizations like NCOS to define the standards for implementing digital engineering. We provided that example of PATS and the development of digital engineering environment to show what's possible when digital engineering tools are applied to the acquisition processes. This partnership with the Air Force is going to aid us as we determine the path forward, continue to share lessons learned, get best practices, and implementing these new techniques and tools as we change our workforce and our culture. However, you know, the Space Force is going to have a little, probably some slightly different emphases as we have different focuses in the life cycle. Sustainment certainly isn't the majority of the expense for space systems, at least as we're developing them today. And we don't have depots that require that wealth of data to maintain the space systems and space vehicles over the decades. Our due diligence processes have served us well over the years with respect to getting very high mission assurance, but we now need to digitize that due diligence knowledge within our command media to do our jobs faster. You know, some of our data products and business processes might be different, but there are so many areas that are in common in this campaign, and that only makes sense for SMC to be the Space Force leaders participating in these efforts to the fullest extent possible. We're super excited to be leading in the U.S. Space Force implementation of digital engineering and continuing to partner with the Air Force's digital campaign. So thanks for this time. Let's work together to truly reinvent our acquisition process and our culture. Thanks again, Dr. Cooley, for allowing me to speak and allowing our teams to continue to work together, and allowing Dr. Tran to talk to you a little bit about one of the systems we're working on. Again, it's a tremendously exciting time to be part of the enterprise, and just want to leave you with Semper Supra.
Outstanding. Thanks so much for bringing that perspective from the Space Force. Yeah, the partnership is, even though we're in different forces now, the partnership is very, very strong. We know we're in the same ecosystem and learning from each other to change the enterprise. Thanks for joining us today. Very much appreciated. So first up is going to be Mr. Tom Lockhart and Mitch Miller. They're going to talk about some of the activities they've been working on to create that integrated digital environment. So with that, let me turn it over to Mr. Lockhart, sir.
Hey, thanks, General Kukuli. Appreciate the time. I appreciate everybody being here. And so I'm Tom Lockhart. I'm the Director of Engineering for the Nuke Weapons Center. And you heard one of our larger programs, Ground-Based Strategic Deterrent. And so I want to make sure everybody kind of caught some of the things that Colonel Bartolome said, but that is one of our premier programs and what we're trying to accomplish in the Nuke Weapons Center. Now, this job of defining the integrated digital environment has been an interesting endeavor. So General Cooley mentioned about 6 months ago, we brought a team together and we started using, the group to figure out what are the nuggets for this integrated digital environment. Can everybody hear me okay? General Cooley.
Yep, we got you loud and clear, Tom. Go ahead.
Okay. I just want to make sure. So let's go on to the next chart. This was a kind of attempt. You heard the three exemplars that we actually talked about. Next chart, please. One was, basically the ground-based strategic deterrent. The second one was our satellite side of the house, and our weapons one. So you kind of got a flavor of three exemplars. But this team that I had, there were about 50 people, we went out and looked at other types of programs. We had 11 Pathfinders. And what we found is what is needed for this integrated digital environment. So on the left-hand side of this chart, we put the big four. We'd love to solve the problem for everything that's out there, but we found some common themes that we really wanted to kind of get after. First is we're moving into this model-based environment. If you look back in the 60s through the 80s, a lot of paper-based products, phenomenal designs then. In the 80s to about the 2000s, we had computer-aided design, computer-aided graphics, computer-aided manufacturing, some really great work there. But now we're moving into this next generation, and it's model-based. And so every one of the exemplars kind of talked about that. Our Pathfinders talked about that, but it is a different way of doing business. And you'll hear this as we kind of go through the presentation. Product management. So it's great to have models, but you need to have some way of validating that. And so you've got to have an understanding of what your current baselines are and track that over its life. So product management was another theme. As we go from research to acquisition to sustainment, test, and disposal. Analysis. So you can take those models and actually run some simulations to get an idea of different variables. And in the past, when we've done this, we've kind of looked at it just from a couple options. You noticed on GBSD, 6 million iterations of design. So how do you actually do that analytics for that? And then the last piece for the engineers out there, we need to be able to visualize the results and be able to provide that to our operational community so they kind of understand what we're actually talking about. The red is actually multiple tool vendors, interoperability with standards. And that's one of the goals of this integrated digital environment. Now, we recognize that it's not that easy. I just put the big four out there. Great, you're all done. But there are some things we have to pay attention to. And, distributed workforce. Today, we've got people, they're at home. We've got people at work. We've got industry partners. And so we've got a group that's out there, and we've got to figure out that distributed environment and how to manage and control that information. Multi-level security. As you put these models together, the tools by themselves, unclassified. You add a little data, unclassified. Now you start putting intelligence, and operational concepts. Now you've got data aggregation. You've got to think about that multi-level security. And a lot of our, program protection programs think about just one specific element. They don't always look at that data aggregation. So we've got to pay attention to that. It's the continuous authority to operate. We can't go back to every tool vendor, on every program and ask for, can we operate this? And so we've got to have an ability to do this continuous operation. And then we recognize the government in certain cases are going to have to own the technical baseline. And in other cases, we're going to have access to that. And that red highlight is it's complex. So it's not just an easy, here's the big four you do, here's the things you have to think about. It's very complex as you kind of integrate those things together. Next chart. So as we go back in history, the Beatty V model, it's been around since World War II. And really what it does at the top line, it takes a system of system design and try to understand that. And then what we used to do is this government reference architecture, it was really an analysis of alternative. And I've highlighted that in red, and Mr. Mitch Miller is going to elaborate on that further, but it really was an attempt to kind of get an idea before we started building a system. And we kind of kept that internally into the government, these analysis alternatives, we put it up on the shelf, and then we said, okay, acquisition community, write a specification and go out and compete that. And so as you move down the middle center part of this V, the first thing we do is we write an RFP, and we said, here's what we think we need to do. You get a contract award, and then you go into design reviews. And it was really a serial process. So the government reference architecture, several years to develop that analysis alternative. An RFP, a year to develop that. Our design reviews, years on that. And so by the time we actually started bending metal, we're 3 to 5 years late to need because the threats are changing and our technology is changing. And we have these emergent ideas coming up. And so that's not how we should do it in the future. And so this gives you an idea. We are doing some great stuff with this old system. We do have models that are currently being done with MBSC. We have some really good computer-aided design and manufacturing along the bottom, and the product lifecycle management there, and the validation verification in the future. So let's go to the next chart. So that's what it is today. Now, what is it going to be in the future? And that big red in the middle is this cloud that we're talking about. Dr. Roper mentioned it, several of the presenters, Cloud One, Platform One. So we're giving you the ability to see into that analysis of alternative. A lot of times we kept that internal to the government and we didn't share it with anybody to make that kind of deciding trade-off. And so that red now is actually getting beyond just government internal. We're actually allowing that to be shared with other people. And as you go down to design reviews, models are going to be different than what we used to do in paper-based products. I went to a design review where I actually sent three people for 3 months out there to actually review all the documentation. By the end of the preliminary design review, we signed off on that. And then we went to the contractor and said, okay, we've established that baseline. What are we going to do with that? They said, well, we've already changed it. We've already made mods to the models. And so part of this cloud is now capturing that government reference architecture as it's being built out. On the left-hand side, it is more than just model-based system engineering. It includes your contractors. It includes our program management. So can we actually model the actual program itself? Financial. We may have to do some cost technical trades. And so do we have a financial management that actually allows us to do that? And contract and legal. And actually, after we get done, we're going to actually talk to our legal brethren. Product lifecycle management. The confidence in a model is you've got to have some physical aspect to actually reference to. And so that product lifecycle management, and I saw a couple of questions about requirements, traceability all the way into the product lifecycle management. That's one of the things we need to capture and then reuse and re-enhance into these models, this trade-off in the left-hand side. And the last little piece that I think is very important is this visualization. If we take MBSE into the Pentagon or into operational, we're not really showing them the relationships we're actually talking about. In the matrix, they actually jump into that real virtual environment. And that's the visualization that we've actually got to come up with. So starting at the top, campaign simulations, the ability to see what the outcome of the campaign is. down to the mission, the specifics, the effectiveness of the system we're actually designing, into operational simulations, subsystems and what their performance are, and back to this other piece that we're actually trying to get after is the cost model, schedule model, and technical models associated with that. I just want to draw your attention on the left-hand side of that V, it's system modeling language. On the lower part, it's extensive markup interoperability, it's XML, the ability to go into these cloud native, and share data, and then the simulation interoperability standards. But right now, they seem to be kind of independent, and we need to get them more closely tied so we can share between the design trades that we actually go through the product lifecycle, manufacturing, and into this validation verification. Next chart. The last one, so for my group, it was about 50 people for the last 6 months. We did have an independent group from a federally funded research side of the house, MITRE, go look at about 260 tools and what they did and how they performed. Some of them were, just specific client server, one-off for one program. Other ones we're looking at is kind of enterprise. But we've identified and cataloged the assorted tools and models, the programs to conduct business across their multi-functions. We recognize about this authority to operate. We can't continue to do these one-offs with our software vendors out there because it takes an enormous amount of time, first of all, to get them qualified, get the authority to operate. And by that time, they've moved on. They've written new modules, new capabilities in the software. And so how do we actually go after this enterprise setup? And the last is this integrated digital environment in the sandbox. And that's going from what we know today is called client server kind of applications. Your Microsoft Office suite is kind of the thought process there, to on-prem, where you're starting to put together this sandbox, this integrated digital environment, and then long-term into the Cloud One, Platform One. So that gives you an idea of the overarching integrated digital environment. But now we're going to kind of talk some specific tenets that need to get accomplished right away. So I'll hand that off to Mitch. Over to you. Did we get it to you, Mitch?
Yeah. Can you hear now? Good afternoon. Can you all hear me?
Yeah, we got you now.
Okay, great. Sorry, my mouse wasn't working on the mic button, so I apologize for that. Good afternoon, everybody. Great to be here today for this exciting topic. You've heard a lot about GRAs today, so that's really what the line of effort that I'm working with a really great team is focused on. But just to set the stage a little bit, I just, as we modernize our current capabilities and develop new warfighting capabilities to solve operational problems called out in the National Defense Strategy that General Bunch talked about this morning. The key goal is to deliver these capabilities rapidly, as the chief said, to the warfighter through agile development, digital engineering, and open architectures. And GRAs are really a critical central part of that equation to fully accomplish the digital trinity that Dr. Roper talks about in his vision. And we've made great strides in adopting and implementing open standards and architectures. However, these standards and reference architectures, they're not harmonized at the weapon system level through a government reference architecture, that guides the adopting program office into quick implementation. And as a result, confusion arises. How to apply whether open standards, for example, especially on legacy weapon systems. So this creates confusion, and the programs aren't harmonized, and the silos within program offices, each approaching open architecture implementation differently, creates diverging and redundant efforts. And this really wastes precious time and funding that we could be using to invest in new capabilities versus integration and tests that Dr. Roper talked about earlier. And importantly, it doesn't begin to take ownership of the tech stack, as we talked about earlier. So to address this, you know, that's really the focus of line of effort 2 is to assist programs to develop government reference architectures. And you can see the definition there, reference architecture provided by the government, as Tom mentioned, to guide the system design, development, production, and sustainment processes. So the GRAs will provide weapon systems the architectural guidelines they need for applying common ontology, style guides, mature standards, the appropriate business and regulatory guidelines and technical constraints and guidelines. We don't want to dictate the solution architectures or be restrictive, but guide and constrain development efforts to increase speed and agility. GRAs will provide really the starting point across programs is really one of the huge benefits. Also remove ambiguity, reduce integration time, and set the standards for model-based system engineering effectiveness efficiently. And more importantly, very importantly, is to deliver interoperability across users and providers of the data, which we have not done well in the past. So one of the key objectives out of this is to develop an approach for standardizing how GRAs can be modeled in these and model-based system engineering tools. And our team, led by Steve Martin out at SMC, is actually leading that particular effort for us under LOE2. If you go to the next chart as an example,
as you're shifting gears, just time hack. We're running a little bit over, so if you could step on the accelerator, I appreciate it. Just about 2 or 3 more minutes if you could. Thanks.
Sure thing, sir. So as an example of the power of GRAs, so the idea is that we're going to have this GRA library providing the unifying principles and industry consensus open standards. So as the example you see down there, there's multiple GRAs that we want to connect. I've got an avionics GRA there connected, and we want to be able to connect that and to an ABNMS GRA or the weapons GRA that you just heard about, so that if I'm fielding a functional use case in COM or a sensor architecture, I'm already meeting the mission requirements for ABMS with those upgrades. If I'm doing a PNT upgrade, I can take that functional use case that's built on a PNT GRA like Regi, OMS, UCI, and FACE, and build that, do mission specific trades to build the objective architecture and really build reusable shared assets. And those would be models, services, and components and software applications that we can share across platforms and that they can use for their final system architecture design for platforms fielding an agile, adaptable, interoperable capability. And doing that, all that work that you see on the bottom 3 tiers there avoids the engineering duplication effort across platforms, speeds delivery, and saves billions of dollars. So in the next chart, again, the strategy is that GRAs will be developed and maintained in a library that can use in this integrated digital environment that Tom talked about, and linked using modern architectural tools to other program office and operational analytic tools to perform the architecture-centric analysis we need for early dynamic and continual analysis. We must build the data architecture for weapon systems that enable us to connect to other analytic tools via common APIs and enable automated sharing of models and software to support analysis at any level across DoD and industry to maintain and share that authoritative source of truth we've talked about today. and to enable multi-domain analysis. This is really the tech stack here. So for example, if a new cyber technology came out, as you see on top, is introduced, we can quickly answer, what the benefit and impact is on the architecture. How does it affect operations? How does it affect performance? What are the trade-offs? And what is the cost and what is the impact to schedule? And then my last chart talks about building the data architecture. The approach is not to create anything new, but to align, all the great work that is ongoing that you saw a lot of today, and leverage the emerging cloud infrastructure and the development environments, and ultimately establish the pipeline to manage, share, and curate data, making it accessible to anyone who needs it. And we're considering this from pre-program record activities to program a record, to ensure that MBSE-based GRA tools are able to produce the evidence they need for the continuous and automated certification. As mentioned, there's 23 different certifications like cybersecurity and airworthiness, and also to do continuous acquisition reviews, as well as the operational analysis I talked about for rapid decision making. So ultimately, we need to build and manage a living data repository using AI ML techniques that allow customization for weapon system program development needs and operational analysis needs. So without GRA standards and the data architecture, the other two elements, Agile and DE, lose most of their power. So this is a very critical part of the Trinity. And that's my last chart. And then Tom, back over to you.
Okay, I'm going to rip through this fairly quickly. So I think we've covered the first couple bullets about migrating to the cloud. We talked about the importance of the architecture. We talked about this digital and making sure that we understand the models there. And so I think you get an idea of actually where we're planning on going. And I know the next presenter, Tom Doyen, our legal side of the house, is back to this own versus access. And so we're going to kind of cover that as our next presenter takes over. It should be the next chart. We can kind of go skip over that. And then, yep, we just did all those. One thing from a requirements standpoint, everybody kind of gets an idea that we are working with OSD, we're working with the Army, we're working with the Navy, etc. So with that, Mr. Doyen, over to you.
Thanks very much, Tom. I appreciate the opportunity to be here today. Good afternoon. Hope everybody's had a good time today. I'm Tom Doyen. I'm the director of the Air Force Materiel Command Law Office in my day job. And next slide, please. I'm going to present the champion of LOE 4 policy and guidance. And today I'm just going to talk about a very specific area, data rights. This is being evaluated as part of my line of effort, LOE 4. We are looking at 5 general areas of policy and guidance, data rights and intellectual property, and we put those into one bucket, acquisition policy, which is another bucket, engineering policy, and requirements policy, and then the 5th is kind of everything else that we find in our policy review. I will say the engineers are way ahead. I think of a lot of other functionals in this area. They've moved out with a digital vision for the last couple of years, so kudos to them. Data rights is probably the most complex of the 5 areas we're looking at in LOE 4. There's a lot of nuance to it. There's a lot of issues to think about in terms of, as has been discussed, ownership versus license rights. And it's also imperative, and we've kept this in our minds as we're looking through this particular area, especially that we have to balance contractor rights in their intellectual property, valid contractor rights, but we also have to balance that against the government's rights and its needs
in this area. And so we do try to keep that balance in mind as we're looking forward. So one of the key issues that we're looking at is determine the optimal extent of data sharing in this digital ecosystem that we're developing. We have to look at who needs access to what, for what purpose, and try and come up with the rule set for that access. And that, it seems to me, will go a long way toward determining what sort of data and licensing rights and ownership that the government is going to need, the Air Force is going to need in that area. You see here a couple of the policies and statutes that we've looked at that may cause some issues in the digital transformation, and we're looking at ways to change those, and again, in concert with our industry partners. But we have to recognize, I think, that the fact is that today's data rights regime in the Department of Defense, in the Air Force, arose in an era where hardware was all. I mean, hardware was the be-all and end-all, and software, for example, was sort of a sidelight to that. Now, changes have been made over the last few years and few decades even, as software has become the center of attention in our weapons systems. But it's still the backbone, if you will, of our data rights regime, arose in a hardware-centric world. And so we have to recognize that. As we go through our reviews, as we move forward with our vision, implementing that vision of a digital Air Force, as we move forward, we, of course, have to continue to assess those necessary license rights that implements the Air Force's digital transformation. But we can't do it alone. I mean, that's really the bottom line that we're looking at today. We cannot do it alone. We solicit input from our industry partners in this area. And the fact is that, as General Bunch alluded to this morning, we're still kind of in the early stages of this as the Air Force moves into the future. We're going to have to work this as we go forward to make sure, again, in the second thought up there, that it is imperative to balance the government's rights and needs with the contractors' rights in their intellectual property and their data. As Dr. Roper alluded to this morning, the Air Force over the years has kind of made data rights a pejorative term. We want to take the pejorative out of that. We want to work with our industry partners to move forward together into this digital world. And so with that, if you have any questions, my contact information is on one of the earlier slides talking about the digital campaign. And I will also attempt to answer any of your data questions in the Q&A section as we move forward. And at that, I will turn it over to Mr. Lanson Connolly.
All right, thanks, Tom. Good afternoon, everyone, and I appreciate the opportunity to join you today and share a little bit about what we're doing. Next slide, please. So kind of the big effort here is how do we change our acquisition process? You know, we've kind of seen visionary from Dr. Roper and some exemplary programs that are already headed down that road. And so one of the things we've been wrestling with is how do we systematically identify and then figure out enhancements that need to be made to allow us and foster this digital environment that we're trying to go to. And so what you see there on the left side is what we call the old horse blanket, which it entails the entire acquisition life cycle from pre-milestone A, where you're in the concept and concept development phase, all the way out to post-milestone C, where you get into the operations sustainment phase and then even into disposal. And so throughout that entire life cycle, there's a number of processes and products and results that have to come about on a regular basis in order for this acquisition machine to move along. And so we have a team of folks that have been looking at how do we do this and an iterative approach to change processes to make them conducive. Because I think what you hear from some of the exemplar programs is a lot of them have had to kind of break new ground, if you will. And so what we want to do is start to break down some of those processes and already have some of this enabled for new programs as they move into the digital realm. And so this will be an ongoing process that we see here over a number of years, if you will, probably in the short term. And then once we get that, we will be ready to hand that over to the workforce that's going to move into this realm. Now, if you go to the next slide, this slide kind of gives you what this whole system look like. We've been talking about an integrated digital environment, and this kind of shows you this integrated digital ecosystem that's kind of enabled by a product lifecycle management system that gives you that authoritative source of truth. And then you see fences there that gives you your multi-layer security, Cloud One, Platform One. So all this is operating in that ecosystem. And then you have any number of folks that are operating off of that ecosystem, if you will. And there's all kinds of things happening, probably more near real time than what we do today. And you can see there's trade space and operation analysis that are being done inside the ecosystem. Contracting language is being looked at, being generated, being sent out to industry. And then we have these acquisition documents that we've had for kind of legacy, that things like acquisition strategies and system engineering documents, technical transition documents, lifecycle sustainment plans. All those are currently done in the Microsoft Office environment that we operate in now. But if you look at this picture, all that's going to be done in this digital realm. And so they will all operate near real time. You'll be able to update as systems changes are made, as updates are made to the baseline. That will allow us to make changes to those substantial documents that help govern the management, if you will, of any one of these programs. And then Mr. Lockhart and Mitch Miller talked about the engineering piece of this and how system development's all done inside this ecosystem. But all this, as we've heard several times today, has to relate into the sustainment phase for those platforms that have a sustainment phase. How does the logistics reference architecture tie back in? So again, it's not an analog transition onto the sustainment side, but everybody's operating inside that digital environment. On the next slide, one of the other things that we've been working on is metrics. How do we measure the progress that we're making? How do we decide whether a program is as digital as we want it to be, or where do we identify gaps that would say, hey, we need to do some more work on a particular program? And so one of the efforts we're working on is developing metrics based on the INCOSE capabilities matrix. And what you see here on the left side are 4 threads broken out into infrastructure, modeling analysis, processes and policies, and then workforce and culture. And then associated with those threads are 7 sub-threads that will allow a program to run an assessment, an internal assessment that's online. And they will be able then to set a target to say, hey, here's where we think we want to be. That would be represented by the blue lines. And then once they do the assessment, they will get a sense of where they actually are. That's represented there by the gray lines. And that then will give a picture either at a program level or perhaps at a center level to say, here's what our metrics look like in terms of digitizing where we want to be as an Air Force. And so that's an ongoing effort. We're making some good progress with that. So let me just move to the next slide here, just to kind of encapsulate what we've been doing to date. As Tom Dorian mentioned, a lot of work going on in statute and policy, and in particular the intellectual property realm by him and his team. And then for us, we've been looking at this whole, how do we take these processes and try to get them ready for digitization? There's a couple of them listed there. Engineering Data Management, Authority to Operate, which I think one of the things you'll hear between our line of efforts, there's a lot of cross-link, a lot of overlap. And so we've been trying to work very closely with the other teams to make sure that we're not duplicating, and yet we're not forgetting anything that needs to be done in the process. We're looking at those big documents that I mentioned there, getting them ready for digitization. Not only are we including clauses in there that you say, hey, when you go digital, this is what you need to do, but how do we put those in our product lifecycle management system so that it's all done digitally? On the contracting side, we've identified about 23 features that we think will be needed to go digital, and then the contracting language that would be associated with that. And in the coming weeks, we are planning to get together with you and industry and show you what we have in terms of these different levels of contracting for a digital program, and get your feedback on it, as I think that'll be very important. And then, as I mentioned, we have been working on our matrix and our metrics to get that ready to field here, hopefully within a number of weeks, and we'll be able to give that to leadership so they can get a handle on where we're at. So a lot of effort there, but a lot of this really does tie into the workforce and culture. And I'll turn it over now to Jackie Channing Lask, and she's going to tell you what they've been working on in that regard. Jackie, over to you.
Thanks, Lanson. So I'm going to continue. I hope you can all hear me. As General Cooley mentioned earlier, strategy eats culture for breakfast, or culture eats strategy for breakfast. Wish it were the other way around. But workforce and culture is going to be a difficult task in moving the workforce to become more digital. At the beginning, General Bunch mentioned that, this is our opportunity to share open communication, lessons learned. This is just a great opportunity. And I've been capturing some of the questions that you've asked, and hopefully I'll roll those into my briefing today. Dr. Roper also mentioned, if we aspire to a level of digital prowess, then, using the increased automation in the tech stack and all the things that you've heard today, and we do this together cooperatively, which would lead to richness, which will lead to disruption, which essentially leads us to a faster build, a stronger build, and a tighter build of our weapon systems. And I'm going to talk to you today about the workforce piece. And one of the questions that was asked was, do we have any challenges coming from calling it digital engineering, or should it be something else? And we have fought with that, and that's why we call this the digital campaign. And under workforce and culture, we talk about the specific areas that we are going to address in each one of our functional areas. So when I said earlier that, we can have a tighter build, a faster build, a stronger build of our weapon systems, it's things like enabling continuous e-design contracts, lowering cost and time for assembly, de-risking government selections, de-risking component commonality required for easier sustainment. So it involves everybody. It's finance, it's engineering, it's logistics, it's financial management. It's each one of them into this integrated digital environment that will consist of assorted tools and models for programs to conduct across all those functions. As I mentioned, enterprise contracts, and then ease of program offices to share, to integrate, and develop models for migration into Cloud One and Platform One. So it's a tall order, of course, and I'm going to go through what we're doing on the workforce and culture campaign. So next chart, please. So the first part of the workforce and culture is change management. And so we're responsible for shepherding the command through this pivotal piece, this digital transformation, right? And in doing so, LOE 5, just to give you an idea of the change management role and how deep this is, we support all the other LOEs that you just heard today in executing this collective vision of digital engineering. And we want to use that digital environment as the cornerstone of messaging our digital future and creating this digital airman. We're going to talk about that a little bit later. And then lastly, create that talent pipeline to increase productivity, cut the time to market, and ultimately enable a workforce well-versed in digital engineering. So how do we do that? Through change management. The first part, we've already conducted a stakeholders analysis, and we're moving to these messaging concepts. Someone asked earlier, how are you messaging to the workforce? What kind of training are you offering? And we're going to cover that a little bit later. But as you can see under phase 0, we work with industry and government. We had briefings from some of our OEMs. How do you use digital engineering? We talked with the Navy. We're working very closely with AFIT on creating the digital airmen and creating that training that is so necessary. And we have a very deliberate change management approach that is based on this matrix team. So on the workforce and culture team, we have teams across from AFMC, and we're leveraging everything that we can, that we understand from not only other services, but within the Air Force and our customers and stakeholders as well. From a data collection perspective, we have conducted a stakeholder analysis. We are doing a training requirements analysis. So based on the plethora of training that's out there, what do we really need? How do we do it in just in time? One of the questions that came up was, how can academia help other than the workforce development? We're looking for metrics, measures of effectiveness. We're looking at modeling and simulation activities. We're looking at analytics. Some of the academia out there, what are your lessons learned in change management, especially during a COVID situation where you are training remotely? So those kinds of things, we're doing a lot of data collection and quick wins and the whole change management. And we're trying to maintain a dialogue with the workforce and of course industry, which is what we're doing today. As far as phase 2 on the resources and metrics, throughout a lot of your questions, I've seen questions on IT tools, model-based systems engineering. How are you working in with the tools? Somebody anonymously said, are you going to just be using PowerPoint? No, we're looking at model-based systems engineering, digital engineering tools, visualization tools, digital architecture framework, and we're going to have to train everyone in terms of using this digital engineering in this change management effort. I also received a question from Janet from Boeing. She said, as engineering automates the way in which programs are managed, we'll need to evolve the management of our systems. And of course, we absolutely have to do that working. And this is another question. Somebody asked how the acquisition instructor course will be playing a part. We are teamed up with the acquisition instructor course as a reinforcing factor that the workforce is key in our adoption of digital management and digital engineering. So we're working very closely with them. On the last part, the execution. So we plan on standing up an execution office, working very closely with all communities, functional communities, programmatic, to truly clarify those roles and responsibilities and what are the expectations for our workforce and how can we really meet the needs of our workforce. Jason Hartshorn asked a question on prioritizing key job opportunities. Do we recognize what this is? And, I would ask the question, what does digital mean? And so we really have to look across the life cycle. And so, yes, we have, as part of change management, we are looking at that. Next slide, please. Another effort that we have under workforce and culture, which is foundational to Dr. Roper's Trinity and digital engineering, right? Digital fluency, and that's training. And so when you look at all of the training that is out there and you compare that to what we need and what we have existing and the lessons learned that we have from some of our pathfinders, what does going digital mean? And so we have put together a team. We're identifying using a true systems engineering process, right? Identifying those digital engineering and MBSE trainings that are out there. We are looking to identify any other tools that can help us, and developing the skills and targeting. And I think this is so key, targeting specific positions and ensuring that they understand what this digital environment means. So along with that, I think we need to look at things that we may look at our personnel and say an electrical engineer, maybe we need a digital engineer, someone who understands what this digital environment is about. And again, how do we manage and how do we work with a digital environment? So, we are all in on this. We are trying best to learn how to train and incentivize the workforce. As we mentioned earlier, this is an industry exchange. So if you have any great ideas, if you have any suggestions, we are looking at the entire workforce. Training will happen on the AFMC side. If you heard that earlier, Dr. Roper answered the question that how are you going to train the workforce? And he turned directly to General Bunch and said that's going to be on the AFMC side. So we're focusing very much on what kind of training to become digital, what are the expectations, and then how will we manage in this environment of a digital for the workforce. Next chart, please. Okay, so when you think about how we are going to work this in and create, I call it the digital airman. And you've heard of digital twin, so you have a digital twin or digital thread for a system. Well, how about that for our digital airmen? So can I make a digital twin for our airmen? And so, it's an interesting question, but we really need to continually ask, how do we mitigate risk, and how do we provide and protect our trusted data to our stakeholders in a timely manner? How do we recruit and hire the best talent? How do we train and develop their skills? We create an environment to not only do the work, but to excel. And we need to focus on our digital airmen in order to do that, which will give them a voice in the mission and challenge them to do more. So it gets back to the, a fast build, a strong build, and a tight build for our weapon systems. And I submit the same goes for a single profile for an individual on their career progression or their leadership development. So in the military, at least in the Air Force, we have these things called 971s. 971s are, I can tell you, they are brown folders that have been around forever. Some of these folders have coffee marks on them from 30 years ago because that folder follows each individual. What if we created that digitally? What if we created a digital airman who was, and I'll use the term of our Chief of Staff of the Air Force, Chief of Staff General Brown, accelerate, change, or lose. And so we have to move forward. We have to make sure that the career progression and the leadership development of our workforce is analogous with where we're going and that is aligned. And so it's very important that we build that digital airman. So I'm going to get back to this 971 issue. If I had the ability to build a digital twin of a digital airman of the future, I could set what those expectations were. I could set their competency management training. I could have a repository of that knowledge development and also be able to work and track the workforce from recruitment to retirement. So career progression, I would have everything at my fingertips, whatever training they needed. It's just another way to look at digital. This happens to be looking digital at our workforce as opposed to perhaps a weapon system, but it still has the expectation of let's make sure that we have a tight, strong, and fast build of our warfighters. And in this case, our warfighters are closest to the build, and so they are our acquisition airmen. Next chart, please. So some of the focus areas and accomplishments to date are listed here. We have created a change management plan, and we are updating that as we move forward. Again, as General Bunch mentioned, this is a dialogue. This is our first information exchange with industry. So any lessons learned, any ideas, I know that academia is on. We're working very closely with AFIT. We would love to get some feedback from academia and how they can play a part. But they're all part of our stakeholders, and I think it's very important that we acknowledge those folks and we team together, because again, once you team, once you collaborate, you build the richness, you build the disruption, and you build that fast, strong, and tight weapon system build. We are currently under review of available digital engineering and digital environment training courses, seminars, workshops, to look at, can we leverage some of the training that's out there so we can move faster in getting our workforce up to date. There's some courses, MIT Sloan has a new course. I know there's some courses at Carnegie Mellon, and there's a lot of online types of courses. So how do we skinny that down and make sure that we have the right training for our workforce in the most timely, most time-sensitive way? We're also looking at badges. As you know, many of you on social media, once you achieve a certain level, you would have a badge. And so thinking it in different terms of what does it mean to be a digital airman, and how can we move the workforce faster in achieving these levels of competency. And then finally, creating that technical support and functional career development plan. We really have to look at the different levels of digital engineering competencies, whether it's for financial management, logistics management, program management, engineering. You listened to Colonel Bartolome. He talked about how they were able to do a critical design review in just 3 charts and be able to manipulate the data, the designs, and look in a very timely fashion on ways to look at a weapon system in a short amount of time with the level of detail that you need. And so that's what we're all about in workforce and culture, is driving that change, driving the culture, and making sure that we can help enable, or that we can enable this for AFMC and the greater Air Force. So with that, I think that completes my briefing. And in a nutshell, digital engineering is how we will conduct business and build the future. So we look forward to industry partnerships, collaborations, and your questions. So over to General Cooley. Thank you.
Hey, thanks, Jackie. Well done. I particularly appreciated your emphasis on this is not just about engineering. This is about every function that we do. And so, although it's very easy for people in the technical development community to sort of focus on that, model-based systems engineering types of tools, as Jackie talked about, there's some great things that we hope to bring to bear with respect to personnel management and that digital airman idea, as well as all the other functionals. So this is a heavy lift, but it's really central to the transformation that we hope to see across the Air Force. Okay, we've come to the portion of our virtual exchange to go through questions and answers. Hopefully everybody has figured out by now how we're going to work this. Questions are submitted, we review them, sometimes answer them, publish them so that everybody can see, and then vote on them. So I'm going to be very, I'll say, democratic in this process, and I'm just going to simply go to the questions that get the most votes, taking that as an indication of what folks are most interested in. So you can sort by the most liked comments, and that's what I'm going to do. I will, in some cases, I may field some of these questions directly, and in some cases, or in most cases, use a lifeline to reach out. So the question with the highest number, I don't know, it looks like Chris Hernandez. I'm not sure if there's any award for the most liked question, but you would get it today so far. And that is, how will Air Force deal with a Northrop Grumman digital environment that is likely different than a Lockheed Martin digital environment? This kind of gets at and there's another question very much related to that. Chris Garrett did, I think, a good answer with this in terms of, hopefully through standards and APIs, application interfaces, other open interface reference architectures and mechanisms of that ilk, and software development, we can cross that bridge. But I think maybe the most important foot stomper in this is where we need industry's help to help us figure out how we collectively move into this digital world. And so with that, let me just see, Chris Garrett, if you had anything else as you've had a chance to stew on this, anything else that you'd like to add on that?
Sir, I really don't have anything else to add. Over.
Okay, thanks. There was another aspect to this that Rich Cutter commented on, which is the second most getter of votes was given by Josh Sting at Boeing. Given the DoD will own the technical stack, how will the DoD balance the urge to standardize this technical stack everywhere with the need to allow innovation and change within this technical stack? Boy, that is a great question. Rich Cutter, I think, provided a very good answer. First of all, pointing out that it is a great question, and Rich, I'll call on you to elaborate here in a second as needed. But his smart alecky answer is as carefully as we can. In a sense, there's always a natural tension between that standards and innovation. Our plan is that by adopting open architectures, we can meet at the interface, permitting agility and innovation behind the interfaces. However, we recognize that the devil's in the details, so please help us to find the balance. I would double down on that. You heard from Mitch Miller and the team talking about the importance of standards. Some of that, the discussion about IP and intellectual property, how do you protect that? Well, we hope to protect that by providing standards and interfaces, defining those, and then allowing the various innovators to come up with ideas that can plug in with that standard interface, but still bring to bear the magic that they may, or technology that they may have created. Rich Cutter, anything else to add on that, sir? I don't know if Rich is still with me. I will assume no. Rich?
Sorry, I hit mute, but apparently I didn't unmute. I was going to say Josh and I actually continued the conversation a bit on LinkedIn, and I'm going to try to find the right software forum in the Air Force where he can actually contribute some of the lessons learned that they've had in Boeing on that particular issue specifically.
Okay, great. Yeah, actually, that's tremendously helpful. That's why we're doing this engagement, is to collectively learn and benefit from that. So I appreciate that. Okay, it looks like the next question was from Jason Hadakiyama. I probably butchered the pronunciation of that. I apologize. And this has to do with, it says the intellectual content of digital twins suggests that more protection will be required, including higher security classifications. What is the Air Force approach to leverage digital, agile, open, and increasingly classified environments? And Rich, rather than try and summarize what you said, let me just turn it over to you to help field that question. It's a great question. I know it's on a lot of people's minds. Go ahead, Rich.
So I'm not sure I interpreted it correctly and answered it as best I could, but basically, what I told Jason is there's really not a good one-size-fits-all answer to the question. We've got a lot of risks that we are exposing ourselves when we adopt open source software and new approaches to how we develop that software, but we also have a lot of modern tools and techniques to help us manage those risks. I think as we broaden our approach to what we're modeling, moving from systems to campaigns and missions, we will expose ourselves to other potential classification issues. So maybe we can flip the script on risk and how we actually manage that. You know, can we balance the risk of not moving or not accepting new things versus the risk of delay and things like that. So I don't know that I've answered the question in a meaningful way, but I think we as a community, we need to be a little more creative in how we approach risk as opposed to how we've done things in the past. And that may not answer the question at all for all I know. Over.
Hey, thanks, Rich. I was just answering another question that was sort of, I'll say, risk related. And there's a lot of questions about the cybersecurity aspects of this as we go to digital. We certainly agree on that point, and you know there are activities in that effort or along those lines. Whether we've done enough, that's kind of a risk calculus, right? There's a lot of folks who are looking at that, but again, I think that this is where we want to make sure that we are benefiting from industry's insights into how we can best address this. There is a lot of really good work on this to address it, but it still represents a key risk. I would encourage you, if you didn't feel like we've answered the question sufficiently or you want to follow up, hopefully you have, well, we've pushed the slides out, the information's out there. Please don't hesitate to contact us. The next most getter of votes was actually Rich Cutter posting. I'm going to leave this one on here though. The Enter the Matrix paper that Dr. Roper authored that basically lays out his vision for how we want to move forward. It is one that is better to understand if you've recently watched the Matrix film, but there's the article that's available, the latest and greatest article that was just refined a little bit late last week, but there's a link for it for everybody. Okay, the next question comes from Carol Erickson for Mr. Lockhart, asking, will the catalog of tools produced by MITRE be available for review? So Mr. Lockhart, I'm going to turn that over to you to field.
Currently it isn't, but our intent is in the future as we can release the data. We don't want to share any business aspect of that. A lot of these companies we actually had dealt with, they said, hey, this is our internal business on the software itself. And so we don't want to share that unless they allow us to release that. But the tools and their current, taxonomy. So some of them were like model-based system engineering, and I'll just reference a couple tools like Cameo, Rhapsody, Sparks EA. And so we're just kind of putting them in that kind of category. Same thing with product lifecycle management, the team centers, the PTCs, those are kind of in that category. And then the visualization side of the house that I talked about, AppSim is the one that we're kind of looking at but there's a lot on visualization. I mean, there's a plethora of tools. I mentioned 260. I think in the last 7 months, we've got over 1,000 that we actually have looked at. And so we're just trying to put them in categories before we release it out to everybody. But we don't want to release any information specifically on the tool vendors and what they're doing with the Air Force. It'll share with their competitors. So does that answer your question, sir?
Yes. Yeah. Hey, thanks, Tom. Sorry, the mute button's kind of slow on the pickup. Yeah, that answers the question. And well, from my perspective, but I will rely on folks to follow up if there is more follow up. Actually, the next question I think is somewhat related. The next highest vote getting from inside the family from LCMC. The question is, there's a statement and a question. I know of at least 3 different architecture tools being used within acquisition programs: IBM Rhapsody / Jazz, Sparks EA, and Cameo. As we are trying to create an enterprise digital environment, are there tools in place to convert the formats to make them transferable between these different software programs, or guidance and structural templates to ensure interoperability? I'll say that Chris Garrett, you may be able to see his crafted response. He said there are various means to move data between these tools. Some of the tools have internal mechanisms, although when I've done them between Sparks EA and Cameo and Rhapsody, and comment Cameo. There's still a lot of manual work. Not familiar with other templates or guidance that have been developed. More research is required, but let me turn it over to you, Mr. Lockhart, as you, I know, have been looking at this closely. Any comments on that very good question?
Yeah, it's a great question, and part of the reason we buy certain tools is their capabilities. And at the top level, a lot of them use the International Council on System Engineering and the system modeling language for the model-based system engineering. But we recognize it's more than that. It's just not doing the system engineering. And so you've got to tag certain data that may be financially related. You may want to tag it for programmatics, et cetera. And so it's beyond what the system modeling language does today. We intend to try to have as best we can, tool agnostic, data so we can share it from one to the next. And that's the ultimate goal. Migrating this into the Cloud One, Platform One, what we're doing with the tools themselves is containerization. It's kind of an iron vault, and it's the ability to kind of take it in there and make sure that kind of operates in the Cloud One, Platform One. And long term, that's where we'd like to go with some of these tools.
Hey, thanks, Tom. Yeah, that was a good answer. This, obviously you put your finger on an issue that we're all very interested in trying to sort through, because we don't want to get ourselves in a place where, I'll say, there's vendor lock. We want to leave flexibility and latitude for people to choose the tools that they want, but we also need to make sure that there's standards. Not everyone has to have a Craftsman Phillips screwdriver, right? Other people build to that standard, to use a very simple analogy. But it's a great question, and we need to think our way through that. Let me move to another very good question, and that is from Jeff Perlak at Pratt & Whitney. He says, has the Air Force thought about setting up a mock program that industry participants can learn about the process? Rolling all this out on a new program may increase cost and schedule due to the learning and adoption cost that must occur. Actually, I had not thought of that suggestion. I will say, let me just make a few comments, and then I'm going to turn it over to Chris Garrett, who I'm going to see if he has any, and the wider team of briefers. My thought on that is we have identified a number of what we call Pathfinder programs. GBSD is one of those. Skyborg is one of those. There's a number of programs who are working towards a digital future, and we're trying to learn from each of those internal to the government. What you're suggesting is can we expose a program to the industry to give you a sense of what this looks like? I think that's a great idea. I don't have any good answers for you right now, but I think it's a great idea. Actually, I see that Miss Janine Lask has turned on her video. So Jackie, let me go over to you and see if you have some thoughts on that one. Over.
Yeah, I think that's a great suggestion, and could even be a mode of training for our own workforce, and maybe be a collaborative thing with industry. So I think that's a great suggestion, and we will pull on that thread. So thank you for that idea.
Any other comments from the team on that one? Okay, let me then go on to the next highest vote getter from the test wing, Chuck Staley. His question is, how do development teams have confidence that the models are correct and interconnected correctly so that we can go so much faster? Models can be useful, but can be difficult even as standalone models. They are more difficult to connect multiple models in a coherent fashion in order to believe the results. I would paraphrase this comment in something that I learned when I was doing model-based simulation or doing training at the Warrior Preparation Center in Germany, and that is that all models are bad, some are useful. And so we have to make sure we understand what the limitations of models are. But he points out a great issue, which is, okay, when you start to connect them up, we may in fact slow ourselves down more than desired. Let me see. Anybody want to take on that question? Tom Lockhart, sir.
Hey, great comment. And the challenge we've got, we're also looking at models themselves, and we're categorizing those into the physics based, so you got a system design and you're at the molecular level all the way up to the mission campaign. And the test guys know this very well. A lot of times they create these independently. And what we're trying to do is with this integrated digital environment is to get the test guys into that MBSE environment to really start thinking about validation, verification earlier on, as opposed to waiting till a system's designed and then fly as we buy, right? That's not where we want to be. And so that's part of it. And so we're really trying to migrate that kind of test thoughts into the upfront MBSE. Once again, we have real data that's out there in the field that we can use for our model validation today. And so part of the reason we're capturing that product management is to start looking at that. We don't always know what a hypersonic vehicle is or artificial intelligence is going to be, but we can validate the models that we're looking at with current data. And that's what we're doing on GBSD.
Great, thanks, thanks, Tom. Actually, the next question is somewhat related, and that is from Greg Brown, who asks, what are the levels of fidelity of the models that you are trying to achieve across the various model types? As models increase in fidelity, the investment required can quickly exceed the return on investment, the ROI, and this has been a barrier to model-based design, model-based engineering, model-based test. I'll just comment briefly on that. That's we agree that you really need to be careful to make those sorts of investments, knowing, asking the right questions of models so that you get answers that merit their use. And that's a decision-making process. So it's not just we're going to do everything. We're going to model absolutely everything to the atomic level, which may be appealing for some of us who grew up as physicists, for example. We might love that, but that's not realistic in terms of getting the answers that we need. So we have to be very careful. We collectively have to be very careful about knowing the limitations of models and asking the right questions to get answers that will inform decisions, because that's really what this is about. I'll just digress a little bit, and then if somebody else wants to elaborate on this, you're certainly welcome. When I was at Air Force Research Laboratory, we set off on doing a number of, trying to ask that really hard question: what system should we be investing in, and what difference will they make in a significant campaign? And the only way to get at that is to do some modeling. But before we started, turning the modelers loose, we put in place the analyst, folks who could help refine and define the specific, particular questions and metrics that we were getting after. Otherwise, the modeling could produce something that really is not that useful or meaningful, and you could spend a lot of money doing it. It's a great comment. I don't know that there's no clean answer except to constantly keep that in mind, that you've got to understand what question you're asking before you dive off and start doing modeling. And so that's just a good reminder. Anybody else want to comment on Greg's great question or point?
Sir, this is Paul. I would like to chime in on this question a little bit. So this is the same challenge that we've been facing for the past couple months to understand, exactly, what we should do, how to improve some of the aspects that we have. And so from that aspect, we went back to the drawing board and look at it and saying, can we implement the existing process for us to get there? And we quickly recognized that, the agile software development process actually aligned really well. We basically went back to the drawing board and saying, what is the minimum viable product that we can work on for the next couple of months, or we can work on for the next, couple of weeks to actually serve the needs of the program management, serve the needs of the user who actually can take advantage of the product that we produce and slowly, incrementally build things up. Aspect of our system, some area we really need to go down to the level of details. How to synchronize user to user. That aspect need to basically really lower the level of detail. But there are other aspects of the system where we can stay at a high level and allow the industry to have the flexibility and the innovation within there. So, we address them case by case and incrementally, build up our inventory.
Hey, great. Thanks, Bo. I appreciate you doing that. And clearly you got your camera working, so good work. Okay, thanks. If I can move on to the next most popular question, if you will. I'm going to call on Mr. Tom Doyen. This is the one about intellectual property. The question is the Air Force prepared to pay a premium for intellectual property or a licensing fee for software use? Are there other business models being discussed? And I see that Mr. Garrett has responded to some things, but let me just turn it over to you, Mr. Tom Doyen, as our legal advisor and expert in this area.
Yeah, hey, thank you, sir. I will say, first of all, I'm not quite sure what the questioner meant by premium. Certainly, the Air Force is going to pay for the data that it needs, and it's going to pay for the license rights in software that it needs moving forward. I think historically that has been our position, and I don't think that a digital transformation is going to change our requirement to pay for what we need. Now, sometimes the payment is kind of part of the price of a system or cost, and it's not necessarily explicitly called out. It's just part of the contract. The answer to that is yes, we are going to pay for what we need and what we need to go forward. But of course, as a program moves along the entire spectrum of its life cycle, we may find out later during sustainment that we have a need for certain rights, data, and certain data that perhaps was not originally envisioned. And people aren't perfect. Planning isn't perfect, but in those cases, of course, we will work with the contractor. We'll work with the owner of the data to see what we need. And I will also say that just generally speaking, we always have to balance cost with what we need if it's extra. So that's always going to be a balancing test. Hopefully that answered the question.
Hey, thanks, Tom. Yeah, there's no easy answer, and as many of us who have been in this business for many years know that the right answer in any acquisition is usually it depends. And so, but you certainly help to provide some of the factors that would get involved with that. And I don't know if anybody else wants to chime in on the intellectual property question. If not, let me go on to a question for Colonel Bartolome. He had texted me, hopefully he's still on. It says, Colonel Bartolome, how is the Air Force working across the DoD to ensure interoperability of the digital thread? Industry is seeing each of the services heading down potentially disconnected paths. Colonel Bartolome, if you're on, I would greatly appreciate you fielding that one. Okay, he may have gotten off. Chris Garrett, I see you touched on that. Chris, do you want to field that one?
Sure, sir. As I'm saying there, and I think you and myself and others have worked with Dr. Magnus and Phil Zimmerman. We have regular engagements with them. This is not easy, but we are trying. And I know OSD is trying on some standard work that we're a part of. So we got to keep nugging through this, sir. It's a difficult task, but we are doing this across multiple areas: C2, NC3, PNT, weapons. So there's multiple areas that we are seeing some movement on, and I think it's only going to get better. Over, sir.
Hey, thanks. I agree. I guess I would maybe. Oh, Tom Lockhart, you have something to add on that one?
Yeah, as part of the GBSD acquisition, we tried to make ourselves as common as we could with the Navy, and so that's one of the driving factors there. And then back to the data dictionary, we're working very closely with OSD and making sure that that dictionary is common across the services and try to reuse as much as we can from the OSD process.
Yeah, that's a good point. I would also just add, in addition to all of that, the work that Mr. Mitch Miller and the LOE team in terms of GRAs, the government reference architectures, we're looking across services. We're trying to identify what are all the various architectures and standards used across the various services. That's a heavy lift. There's a lot going on, but we're trying to make sure that the right hand and the left hand are talking, or at least witting of one another as we go forward and do that. This is frankly an area where I think industry can play an important role and help make sure that we're connected. We all know it's a complicated enterprise. We also know that human nature has a sort of a not invented here predisposition. And so trying to make sure that we are coordinating and leveraging across the entire joint community is in everybody's interest. Over. Tom, did you have something else to add on that?
Just one more data piece, sir. So it's not just DoD. So with ground-based strategic deterrent, we're actually Department of Energy, National Nuclear Security Agency, and then our federally funded research side of the house. So we've got real good participation from aerospace and MITRE, APL, that are actually trying to help us out as we move forward.
Yeah, good, thanks. Okay, the next question which comes from Dr. Joe Mitola, a great question, and he says, from press reports, the catapult and elevators of the currently deployed challenged U.S. aircraft carrier were digitally engineered, had digital twins, but didn't work as planned. Laws of physics may not have been captured in the models. Any thoughts on how to address these types of shortfalls going forward? And I guess I decided to attempt to field that. It's a good but tough question, and there's no clear answer. But it points to clearly a fundamental lack of understanding of the physics that was not properly modeled. And so there's always risk in using a model of any kind. In fact, the question is have we fairly and accurately understood what those risks are, and have we taken steps to mitigate those risks? That's a program by program challenge. Clearly in that case, or it sounds like, I'm not familiar enough with it, it sounds like they did not take the mitigation steps to really understand what the limitations of their models were, whether or not it was actually accurately capturing the physics. But this is the challenge for every program. And I would just point out that this is where the test community reminds us that this is why they exist, because we can't necessarily always model all of the physics that are going on, so that at the end of the day, nature is the ultimate computer and will do the calculation for us in terms of exactly what will happen. And so at the end of the day, we got to get out and test. I don't know that I have much to add. I will open it up to others who may want to add on to this, but clearly understanding the potential limitations of models is absolutely essential. And in fact, when we aggregate, models to a higher level, we are certainly going to miss more subtle features that may be going on at a physics level. But that's something that all engineers, decision makers, physicists, everybody needs to understand that and figure out where are there substantive risks and what can we do about that. Anybody want to help me out on that one? Okay. Oh, Tom Lockhart, sure, go ahead.
So I would just, Dr. Roper in his paper hit to, I think Tesla is trying to get down to that level, and I think the Formula One. So I wasn't going to change your answer, sir. It was spot on, but I think industries go in that direction. We need to also think about that as we move forward.
That's a great point. In fact, I think the Formula One example is a terrific example. of trying to figure out, okay, how do you model it and able to iterate rapidly? So there certainly are some examples out there. Thanks, Tom. Okay, the next high vote question comes from Ian Marks. He says, when applying digital engineering into a secure environment, how does the thread maintain connectivity if the parts are in different program spaces? I'm going to look for a lifeline to help me out on that one.
Cloud One, Platform One, they're trying to start at non-secure. They want to do secret and then all the way up to SAP SAR. Some ways of actually preventing that leakage from one multi-level security versus the other is with fences, and it kind of segregates that data. And so I think that's one attempt. The other way is just to isolate yourself, and I don't think long term that's going to be the answer. And so that's why we're trying to move into this cloud environment.
Yeah, thanks, Tom. Yeah, no, that's it. That's exactly what the thinking is behind that. Let me move on to let's see. It looks like we have some shifting around. People are still on and voting, which is great. So the next question is, what challenges do you foresee with our workforce to think and learn in a model-based environment? I think I'm going to turn to Miss Janning Lask for that one.
Thanks. Yeah, I saw that one coming up fast. We did talk about this as early as last week, as recent as last week, and one of our members of the younger junior workforce said, it really is, what does it mean to each person, and how can we help? Of them asking, how can I help be digital? And she said, ma'am, my mom works in finance and I'm just not sure she knows what it means to be digital. And it made me chuckle a little bit, but she said, if I can show or demonstrate what digital means to her and how she can make things accelerate, and I go back to accelerate, change, or lose, and Dr. Roper's comment about we must accelerate, she said, I think if I could demonstrate that to my mom and how she could, go faster with digital automation in her financial management job, I think she would be very excited about digital. And so those are the kinds of things we need to get with the workforce. We need to make sure that they understand what the expectations are, open it up for, the realm of the possible to increase, make things go fast and accelerate. So we know that there are some challenges out there, but again, we must accelerate, change, or lose. Thanks.
Hey, Jackie, while you're on, there's another question that just popped up. These workforce questions are popular and get lots of votes here. This one said from Deborah says, are we partnering with the community, or excuse me, with the college university community to create curriculum to support ready to go workforce?
So yes, and I know Rich Cutter mentioned some of our DAU training. We are reaching out to colleges and universities, trying to get a better understanding of the training that they have available, what some of the lessons learned that they have. I have a team that is specifically working on that. We also have folks that are looking at online training from the local universities, well, not even local, just our national universities and what they are offering. So yes, we are working to message to the universities and academia where we need that sort of workforce development and how they can help us in other areas of measures of effectiveness or modeling and simulation opportunities and other parts with respect to a digital environment.
Okay, thanks, Jackie. No, that's this, and in fact, this is an area, as Jackie had pointed out, where we want to partner with you all, industry, academia, to help us figure out how we can smartly leverage, because this is about the national defense. This isn't about DoD or whatever. We're all in the same ecosystem, so we need to help each other figure out a way forward. So I think that there's another one on a training thing. Rich Cutter kind of addressed this. So Rich, I'll probably lean on you to answer this. But from Tim Walden, he says, for training, have you considered the need to train at the finer grain of skills, Python programming, data sciences, than the traditional software engineering, mechanical engineering? The future of the workforce is fluid stack of skills that doesn't resemble the current stack, 4-year degrees. This is going to disrupt the hiring and incentives of our industry. I would just, Rich, I'm going to turn it over to you because you answered it. I would agree this is a real challenge of how we figure out to get the right training. Rich, over to you, and then Jackie may want to comment because this is kind of that workforce development question. But Rich, go ahead, first crack.
Yeah, so Digital U is one of the approaches that we have in the Air Force. It's a front door to Udemy as the reseller, but it has a lot of really small courses on some of the what I called hard topics, Python, other languages, how to roll out cloud, how to use Kubernetes and managing containers and so on and so forth. But it's also got some of the emerging softer skills such as maintaining change management and leading new projects and even things like how to foster emotional intelligence. But there are other initiatives as well beyond Digital U, and Jackie can probably speak to some of those better than I, so I'll turn it over to her.
Thanks, Rich. The other thing that I wanted to specifically mention on this question is, Dr. Roper mentioned the digital fluency that's needed across the life cycle. So I can tell you from the sensors director and Air Force Research Lab that our folks are getting trained in all the tools, as well as the folks in AFL-CMC all the way through to the Sustainment Center. So the better that you can have that consistent usage of tools and the ability to understand across the life cycle from cradle to grave, the better that we'll have in making this cultural change. So Rich is correct. We have different types of training that are out there and different types of tools. We have the Death Star that a lot of folks in AFL-CMC are aware of, and that training, those training tools are specifically for the digital engineers, but we're going to have to expand that to all folks across the life cycle and in all functional areas. Thanks.
Thanks, Jackie. Okay, I'm going to give Jackie a break, and the next question is going to go to Mitch Miller because I can see this where this is going. And the question is, MBSE itself is important, but it does not provide the glue to create the digital thread across all the lifecycle data. I'm thinking something like linked data or OSLC, Open Service for Lifecycle, to link all the data and enable integration of federated data. Mitch, do you want to talk to that in terms of how to approach the data across the lifecycle challenge?
Yeah, can you hear me? Yeah, this is.
Yeah, we got you now.
Okay, I'm sorry. I've been looking for how to view the question. So can you just briefly go? What was the main emphasis behind the question? How do you manage data across the life cycle?
Yeah, it's really the glue to create the digital thread across all the life cycle data.
Yeah, well, that's a heavy lift that we're really focused on how to do that. We believe that we're going to have some sort of governance structure in place to be able to do that and to do that effectively. And I would think that it would be a governance structure that involves industry as well. And so that's not quite in place yet. And to be able to do that, we definitely want to do that from the beginning of the life cycle through all the way through sustainment and PLM. There's some efforts going on in PLM that we're working with and how they're starting to formulate the data now. And then, but how do we make sure that that can accommodate us early in the life cycle is one of the things we're working. We haven't got it all figured out yet, so would love to hear from industry on any ideas of how to accelerate that. But we are thinking we have to have some kind of governance in place to be able to establish how we curate data and manage it throughout the life cycle. I know I didn't answer that very well, but that's where we're at. So
thanks, Mitch. I appreciate that, and that's just to give you a sense of where we are on this. I guess let me just elaborate a bit, because I've been spending with Mitch and the team really trying to get our brains around that very question. It's a tough question, and I'll say I'm aware of two camps, and I'm trying to sort out the ground truth, if you will. There's a camp that says, in my view, what you need is a good data architecture and governance to sort of drive everybody to allow their data to be discoverable and all those kinds of things. And we have examples in which that works. There's another camp that says, no, that's not nearly as important as tagging all of your data with some sort of a meta tagging scheme, so that it's largely, I'll say, unstructured, but the data is tagged such that it can be found and discovered and those kinds of things. My sense is that the truth is probably somewhere in between. There may be circumstances for both, but as an enterprise, we are in the position of really trying to think through what sort of guidance do we provide to programs to enable that. And I welcome the dialogue with industry as we think through. I'll say those two, approaches to exposing data and making it, life cycle applicable and easy to get at. If there's other questions or comments from the team, please help me on that. But again, this is something that we want to have an engagement with industry, the smart folks in industry. Let me go on to another question here that is a great question, and I think this is for Mr. Lanson Conley probably. It says, can you share, from Anonymous, can you share these 23 digital features of new contracts? Let us see what you are thinking as we are doing statement of work right now that could be informed by this work. Lanson, comments?
Hey, sir. Yeah, so we are planning to share that here in the next couple of weeks. We'll probably set up another industry day type. I think what we're gonna look at doing is taking what we have already and posting it to something like Beta Sam. Put it out there for comments. Once we get the comments, then we'll host a live event like this or a similar event like this, and have the dialogue with industries. So absolutely, we're interested in having that discussion and making sure that we get industries' inputs on this. Thank you.
Hey, thanks, Tom. Actually, I would just add, I'm very excited about what the team has done to sort of identify and refine these 23 features, but we want to be informed with industry on this. So please watch Beta Sam and contact Mr. Lanson Conley directly to make sure that you're in the loop on that. We very much know we need to have industry's input on that. Okay, the next question is, and I'm just going to go for a couple more. A couple more minutes, and then we're going to call it a wrap. So let's see. The next question, again, I think this may be Mr. Conley's to field. It says, how do you get the contracts team on board with doing business digitally? Is your approach eliminating the need to deliver documents, or do both models or do both models and documents? So I know that there's some answers there. Let me see, Tom Doyen, I see you answer. Let me see if you have something that you'd like to add, and then maybe Lanson Conley would like to comment on this as well.
Sure, sir. Yeah, I see this as an issue, and leaving aside the issue of electronic documents, which I can discuss for a few seconds at the end of my answer. But in terms of the workforce, I see this as a issue with really two co-equal solutions, as I said in the answer in the chat. I think that acquisition policy needs to be more forceful in terms of moving contract personnel toward implementing a digital framework in their acquisition strategies and in their contract documents. I don't think that there's a lot of policy out there currently that acts as an impediment. So there might be some things that are used as excuses at times, but I don't think there are many impediments. But I think we can do a better job of having acquisition policy that incentivizes and moves people and pushes them, if you will, into implementing this digital vision. And then I also think that a part of this is, again, the training of the workforce to make sure that they have the right culture and the right mindset to move forward in this. Now, in terms of electronic documents, there's probably going to have to be some changes made to the FAR and the DFARs, and that is being examined and looked at.
Hey, so I would agree with what Tom said. And certainly, I think we're going to have kind of both going on at the same time, right? We're going to be starting new programs that Dr. Roper said, and those are going to go digital from day one, and then we're going to have some legacy programs that are going to do mods and upgrades, and those will try to go at least digital. So I think what our folks have been trying to do on the initial side here is look at what do we have to do to kind of today's traditional documents, contract language, to say, here's a tool set that says, if you're going out to do a digital acquisition, these are the things you need to consider: seed rolls, DIDs, what level of model acquisition are you doing, and all those will help in the process. And then, of course, down the line, we want to be able to be inside that integrated digital environment where all these things are kicking out inside that IDE, if you will. Thanks.
Thanks, Tom. Thanks, Tom. Okay, I see last two questions. Both of these are great questions. I want to tee these up, and we'll answer these, and then we'll call it. And then I'll thank some folks, and then we'll call it a wrap. So the first question says from Anonymous, and I think Chris Garrett has started to answer this. So Chris, I'm going to probably lean on you, and that is there a push for certifying designs with trusted high fidelity models instead of testing? Chris, you want to field that one?
Oh, sir, I think there's no doubt that we absolutely want to do that. Industry has shown that they're doing that. And our models today, for example, I immediately think of CFDs. I think of the old frozen chickens that we used to shoot at the windows that we're now doing in many cases with high fidelity validated models, and that's just the tip of the iceberg. So I think there's no doubt that when we have a verified, trusted, high fidelity model, economics and just sheer common sense pushes us in that direction. And sir, if you don't mind, I don't know, down the question below that, does the USOF envision requiring industry to use specific tools? And we would say no. We don't envision that. We envision establishing the interfaces and the mechanisms, as you've already talked about, with data by which we can exchange the right data, the right models, and so forth, that allows industry to be creative and innovative, and also allows the Air Force to do the same thing. Over.
Hey, thanks, Chris. Actually, that was the final question I was going to end on, and give kudos to Brenda McCourt for a very good question. I'm surprised we didn't get to it earlier, because it's something that is on our mind, because we don't want to drive, as Mr. Garrett said, we don't want to drive folks to a single solution. What we want to do is provide some agility, provide for competition. That we don't want to get necessarily lock in on a particular tool for everybody. That said, in some cases, we have to make decisions to move out as an enterprise. And so we're trying to balance that so that we can work as an enterprise. One of the examples that I often use is when you think about Amazon or Walmart or some of these, very large, enterprises that are doing things digitally, doing things that just amaze us as they send you pictures of the package that just got delivered to your front porch. Some of those kinds of things. That doesn't happen unless you go into it with sort of a digital enterprise thought in mind. And so we recognize there's probably going to have to be some decisions on our part to create that enterprise work like that. But to the extent that we can, we don't want to lock industry into things. What we will do is communicate what it is we're doing so that you all can make smart, informed decisions and help us to try and stay as flexible and agile as possible. I think getting back to that standards and data format discussion we had earlier is really central to that thinking. So that's all the time we have. I'm gonna call it a wrap at this point. Let me first of all say thanks to Mr. Nick Schaus, who's done just a remarkable job of herding all the cats to get this together. General Bunch already recognized the great digital team folks who are working this behind the scenes to make it all happen. I have to say I am pleasantly surprised and impressed with how this came together in spite of having a initial delay in getting Dr. Roper on. I think that was about the only hiccup we had with the technical. So huge kudos to our technical team who made this happen. They just put up the slide for the points of contact. You've heard from, I think, virtually everyone here today. Yep, you've heard from all of the folks on that list at some point. Please don't hesitate to reach out and talk to them if you have follow-up conversations. I also am available. This is an enterprise thing. We are not going to be successful unless we have our industry partners and the broader partnership as both Dr. Roper and General Bunch talked to. Thank you very much. The one last thought is the feedback. We are living in through a pandemic. We've had to change the way we do things in significant ways. And we hope we get better at it all the time. So we would very much appreciate your feedback for this event, our ability to hopefully communicate out what it is we're doing so that we can keep the communication channels as wide open as possible and continue to build partnership with all of our within the ecosystem and all the great enterprise folks that are out there. That's all I have. Let me see, I'm going to pause for just a second and see if I've forgotten anything from the SMART team that you've been hearing from today. And Nick Schaus. I don't know, Nick, did I forget anything?
No, sir, I think everybody did a great job. I really appreciate it. One thing is keep looking at that Digital Cam website for the video and hopefully more answers to these questions and any continued conversations with industry and academia. Over.
Yeah. Hey, thanks, Nick. Yeah, we have got a lot of great questions. Haven't answered all of them, but my hope is that we'll get some follow up on many of these, as many as we can possibly approach. Nothing else from the team. Let me just say thank you again. This was a terrific team effort. Appreciate everybody's time. Hopefully you found this useful. If you, we are looking forward to your feedback and looking forward to the continuing dialogue. With that, that's all I have. Everybody have a great Monday and the rest of the week out here.